Hey guys, what's up? Um, Last time we did a couple of products and a game product as well. And thank you for all the feedback that was there. Thanks for coming to my stream again, obviously. From bottom of my heart, a very big thank you. So we are doing something again. We are trying to do something cool again. If you are interested in this field, then yes, you will find it really cool. Um, Today we are working on creating algorithms for different various products. Most essentially, we are trying to design or learn to design a recommendation algorithm. Okay, so what is an recommendation algorithm? If I have to just give you a bookish yet a little bit of derived derivation. Recommendation algorithm is nothing but set of rules over functions working to help access the segregated data. Now, this segregated data should be tagged very importantly into different categories. Okay, that is pretty much it with the recommendation algorithm. What is recommendation algorithm? I'm sure Google has some great bookish definitions by the way, guys, just FYI, um, like the one person whom I looked up to for product management, like the epitome of product management, I thought is leaving X, Nikita Beer. I really looked up to Nikita Beer. He had very strong sense of product and how to make things work in a very hackable fashion. And I feel this is what product management is for the companies that actually work at a very high stake speed. And Nikita Beer has done a very phenomenal job with X. He totally totally changed the way X used to work. Like um, uh, like earlier, we would associate the hashtags with Twitter, but now it has already been changed. Everything of it. And Nikita Beer had just announced today, actually last night, what it is time. Yeah. So he had just announced that he's parting with X, but he will work with them as an advisor category. Nikita Beer's bit of background is that he did some BSc or BA something, and then he started his own app development studio. And they were building multiple products. They had a good investment with them, and they were building products. And one of the product got hit. It was, I think, Gas app. Gas app was nothing but a social media app for a bunch of high schooler teenagers. You could just ask um, your friends to rate you anonymously in your school, basically, like in your school group. That was the function of the app. Like and he eventually also admitted that he copied the whole app from, there was an Arabic app called Saraha, something like that, and he copied the idea from them, but the app got viral and it reached the top. And then again, I think he worked on something then he sold this app to Facebook. Sorry, it was called TBH, to be honest. The TBH app it was, and it was acquired by Meta in 2017. And then he worked with Meta for 2 years as a PM. And after that, he left Meta, made the same app, same concept to be TBH, named it Gas, and it was acquired by Discord in 2023, just 5 years later. Same idea, same app. Okay, just name changed and UI changed. Got acquired by Discord, and he worked with Discord for 2 or 1ish, I think, some good years. And then he left Discord. He was working in as a like advisory PM, and when he joined X, he was appointed as head of product by Elon. And when did he join? He joined last month in July only. So he worked with them for whole 1 year, and he changed a lot through the whole year. And actually, he made the whole product very exciting. Like he made the art of product management very exciting. Just watching him work on the product for whole 1 year, excited me much more to come back to the art of product management. Those who know that I had left product. I had full idea of leaving the product management, and this is me, by the way. And I just wanted to go into the game designing phase. And game designing is actually good by in itself, but just I love what Nikki W was doing, and I just had to come back to work on this product. Um, so yeah, that's about the whole thing and introductions. And recommendation algorithm, coming back to algorithm, it is a tool that uses data and artificial intelligence to suggest products, videos, or posts you might like. Okay. Yeah, exactly that definition. And then that more technical definition is like it it is a set of functions and rules to help quickly access the already segregated data, but provided this data is already filtered, okay, or named, like whatever the columns, or if it is a like DB, the DB is the column or the row of the DB is named, and it all of them has unique IDs. So yeah, this is recommendation algorithm. Okay. Where have you seen recommendation algorithm? Netflix, Spotify, Steam games. Like when Netflix show you all the movies that are there, or like when you access Netflix, the all the shows that it shows you. And then when you go to Spotify, the songs it all suggests you. For example, these are different categories of movies Netflix shows you, like a police detective team, TV drama. This is one category, and they have Peaky Blinders, Zombie, Dark, The Method, all of that stuff. And then it is a critically acclaimed witty shows, like some witty shows, like they have BoJack Horseman, The IT Crowd, Big Mouth, The Good Place. My Next Guest, by David Letterman. It's very pretty witty show. And then Emmy-winning TV show, US TV shows like Rick and Morty, House of Cards, How to Get Away with Murder, and everything. Orange is the New Black, The Good Wife. Though you can put Rick and Morty in other TV VT shows as well, but or the How to Get Away with Murder in the police detective TV drama or something like that. But there is a like, it depends how much weightage it wants to show you. Okay, we'll come on to what is weightage. Right now it just you got to learn that what is recommendation algorithm is. Recommendation algorithm is like helping, like you will tag all of your stuff, and then later on the tag stuff is picked by the set of rules that it feels that it should be there. Those set of rules should be there to access the data in a better way. Okay, to access your, for example, in previous Instagram before 2020, till like before even Meta acquired it, we used heavily used hashtags under our pictures, and how the explore would function would work. This is Meta, before Meta acquired Instagram. It was very random selections of images. So first of all, there was a random function. Today I feel like working on a doc. Okay, so it was a random function. Okay, so the images would just show up randomly to your explore feed. This is Instagram 2013. Here it is. Yeah, this is the stuff. Yeah, this is the UI of Instagram. Those who don't know, this is from 2013. Okay, this is how your profile would look. This is the whole shebang of home feed, and this was the explore page. And supposedly, they had first had implemented the random function, and you would just refresh, and it would show you other random pictures. Then they started personalizing it. How did they personalize the whole random function? Okay. Maybe I should use instead a doc of calc. Let's do calc. Yeah. I use heavily use Google Sheets and everything. So yeah. For example, you just posted picture. Okay, you just posted a picture, and then you started posting under that hashtag selfie, and then you started posting under man, and then you started posting under that um, dog, and then swimming. Okay, then you started posting these pictures. Then another person posted, or maybe you posted another picture. It was called picture B. Okay, um, and then in this you posted food. Then you hashtagged it as um, dinner, and then maybe family. Okay, so when now these are two of your pictures. Okay, these are two pictures on Instagram. This is like totally new Instagram we are thinking of. Now, when a new person would come in, what would they think? Is it getting complex, guys, for you? Let's just try it. Then I will maybe move on, take up an example of Netflix. Okay. Actually, I had initial thought of giving a Netflix example. I will come on to just in 5 minutes. Okay. Even lesser than that, sorry. So yeah. Now a new person comes in. A new person comes in, and then new person says, new person also starts posting pictures. His first hashtag is selfie. Okay, and then his second hashtag is family. He posted all of this. Okay, so now my algo would pick it that okay, they would think that this new person, let's just call him Roger. Okay, and this first person, call him maybe Niket. Okay, now this Roger person likes selfies and families, so we should more show more of these pictures. So what he looks for in his DB, he looks for like images with hashtag food, and then also images with hashtag selfie. Okay, which one comes up? Pick B and also pick A. Okay, he picks up selfie, connects selfie with selfie, these two. Okay, and then he connects these two, and then sorry, this is not family. This food is family. Okay, now and then he connects family with family. He connects these two. Okay, and this is how pick B also gets suggested to Roger. Okay, so this is it only, the only functioning of this algorithm, initial algorithm. Okay. Then set of rules comes in, like this was whole hashtag based recommendation. This was working till 2013 or maybe 2015. This was, we're talking to 12 years ago now. Okay, this was working at that time. But now, what do we have here is we want to recommend more pictures because Instagram UI is this big. You cannot just show two pictures to the person. Okay, maybe more pictures, people would come in, and then the Instagram would eventually fill up those places. Okay, but you cannot like always think of like what to show and what not to show. For example, there is some bad picture or there is not some bad picture. So then rules came into that picture. Okay, more rules came in, more complex rules came into picture. But we will come on to it later on. What are the complex rules and everything? Okay. Or now, maybe let's see another example of what algorithm works. For example, you are going on to Netflix to watch a movie, okay, and you watch, let's say, Harry Potter, okay. What are the hashtags you associate with Harry Potter? First of all, magic, of course, okay, and then kids, of course, and then maybe it's a Christmas movie, okay, Christmas movie, okay, and then what else you associate with Harry Potter? Um, what else? What else, guys? Quickly, quickly, tell me. What else do you associate with Netflix? Probably give me one more. Just give me five. Give me five. Just give me two more. Um, maybe let's say family movie is the family picture, and then last one, give me a last, maybe cozy, okay, cozy stuff we associate with this Harry Potter. These are Harry Potter now, what do you call, Harry Potter hashtags, okay, you associate with Harry Potter now, okay. Now what do you think of like when like these are different hashtags with magic, Christmas, and then family, and then cozy. These are different hashtags, okay. But now there is this another movie. Let's just say, what's the movie? Let's just say it's Home Alone now, okay. Again, same, Christmas, okay, family, and then kids, okay, cozy, maybe yes, okay, magic, no, not magic, um, robbery, okay, new hashtag robbery in this one, okay. So now, Home Alone almost have four of the same with Harry Potter, but just one is different, okay. So now let's think of another movie. Let's just say The Dark Knight, okay, or uh, let's just say Die Hard, okay. Christmas movie, yes. Um, family movie, maybe no. Kids movie, no. Robbery, yes. Action, yes. Okay, so these are the stuff, okay. And so if we look further ahead, now when a new person would come in, okay, a new person would come into the picture for this to watch a movie, okay. Next time it has picked up, for example, you're constantly watching these movies. What I am going to assume is you like magic, you like Christmas movies, yes, Christmas movies for yes, okay. um so what do you like? What does Niket like? Niket likes Christmas movies, okay. And then maybe we can also add within Die Hard, you guns blazing, and then what else? Fights, okay. All of it is same. Let's just say crime, okay, crime, okay. I will come on to it that why, yeah, those who know. So it will just assume Christmas, okay, and then maybe kids, yes, kids movies, yes, okay, and then what else is common in between? Nothing. So yeah, nothing. Robbery between these two, okay. So these are the like those similarities between these movies. Okay, now a new person would come in, and this new person would just see. like what do I want to watch? The Netflix would ask, what's your favorite genre? These are the 5 categories or 6 categories of genre, and he will choose, and then he can get to it. Okay. Um, for example, um, I have watched these movies a lot. Okay. So next time, what movies it would recommend me? Okay. Let's just say, would there be chance of suggesting me Lord of the Rings or The Dark Knight? Which one has a higher chance of showing up in my recommendation? Okay. Um, Christmas, or maybe we should do something else. What else is movie? Let's just say Alice in Wonderland. Okay. Let's just say Alice in Wonderland. Or maybe what else is a Christmas movie? Um, let's just say The Grinch. Okay. The Grinch. So which one has the higher chance of coming in my recommendation? Okay. These are all the categories. So Alice in Wonderland is categorized as magic. Yeah. And what else is there? It's for kids. Yeah. Is it Christmas? No, Christmas is Grinch. Okay. Alice's Wonderland is a family movie. Yes. Grinch is also a family movie. Yes. Okay. Alice's Wonderland is a cozy movie. Again, it's a cozy movie. Christmas we are done. Family we are done. Kids movie. Both of them are kids movies. Okay. Which one is cozy? Robbery. Probably Grinch. Yes. Okay. Guns, robbery, and all of that. It wouldn't matter. Crime, you can say, yeah, Grinch. So, which one is more likely to show up in my first recommendation? Just FYI, Niket liked Christmas. Okay, then Niket, because Christmas appeared in all 3 movies. So I wrote Christmas, the first one. Okay, and then Niket liked probably family movies more. Okay, family movies, yes. I think second is cozy because 2 times it is appearing, and then robbery. Niket also likes robbery. This is the system thinking, like what do I like? This is now system is recording what do I like based on the movies I saw. I just saw the Harry Potter movie, Home Alone movie, and Die Hard movies. I just saw all of these movies, and the probably system things now. He is categorizing what do I like. He has just taken up all these hashtags and ranking them based on what do I like the most. For example, Christmas came up in, so he ranked that Christmas came 3 times. Okay, family came 2 times, cozy 2 times, robbery 2 times. What else do I like? Um, um, what else do I like? Okay. Um, Christmas has happened. Kids, yeah. Kids, yes. Kids. Okay. What else? That's it. Yeah. So that's it. And then probably the rest of the scores, like cozy is done, family is done, Christmas is done, kids is done, magic, magic is one. Magic is one, and then Christmas is done, family is done, kids is done, cozy, robbery. Shocked that Home Alone won. Okay, then probably crime, and then guns, yeah, and then action, yeah, and then robbery, yeah, okay, not robbery, sorry, my bad. And bro, come on, don't let me down like this. Yeah. So this is what the algorithm has kept my score as. Like Niket likes Christmas a lot, so I will going to show him Christmas movies, family movies second. Okay, all the movies with Christmas hashtag are gonna show up a lot on my doorstep. Okay, so Grinch is one that is gonna show up. Okay, and then what is the score of Christmas based on this score now? Okay, what is the score of Christmas? Um, Christmas was 3. Okay. Family was 2. Cozy was 2. Kids was 2. Robbery was 2. And then crime was 1. Okay. What about magic? This one, Alice in Wonderland. Um, magic was 1. Kids was 2. Family was 2. And then cozy was 2. And then kids was 2. Okay. So this is it. What's my final score? Sum is 9. Okay. And what about this? Sum is 12. So who won? Obviously. Who won? I'm going to paint it green. Oh, sorry. I am going to paint it in the greenish color only. Yeah. And Alice in Wonderland probably in would look good in orange. Yeah. So who won for me? Um, Obviously the Grinch. So Grinch is gonna show up on my first priority recommendation, and Alice in Wonderland maybe later on. All the movies would with the highest score would show up a lot more, and then all those categories would show up a lot more than the other movies. Okay, like it would just say that hey, you would love to watch other Christmas movies or something like that. Okay, it would I would have here Christmas movies or maybe something else. Other what was my favorite? Family movies, something like that. Family Guy. I can get a recommendation of Family Guy most likely. Yeah. So that's that about movies and Instagram. That's how the basic of the algorithm works. Okay, but now within these rules comes in like rules like filtered content, for example, if something is abusive, it should be filtered out. I have said that I'm not interested in this particular segment, then it will get negative scored. We will come on to it, like what is the weightage of all of it. We'll come on to it, like we are just getting started right now. This is the first glimpse of um, what do you say, the first algorithm. Now we are going to work and function on it further ahead, like what how to build further ahead. Okay, on top of it. That's that. um so today's topic is recommendation algorithm. Okay, so yeah, we're drinking water. This is going to a very heavy lesson, guys. Shall I write the definition again? I just write it. What is, those who don't want to probably can skip further ahead. Okay, to the next chapter. I am going to take some time to actually write it. I'm sorry guys, I have a teacher somewhere in within me who loves to do this. Like, who loves to do the notes thing. To the users. It is based on their historical data. Okay. Example, likes, for example, behavior, preferences, and context. Okay. It is then surfaced automatically without any explicit search. By the way, guys, do you know what is an elastic search or something? Okay. I will cover a new separate video for elastic search. Okay. In layman terms, if I have to define it, it is given everything we know about you user right now, which items from our catalog. Guys, you can always run this episode at 1.5x or 2x speed. Should we showing the next? I feel I speak very lot slower, so those who want, they can probably choose to, 1.5x or 2x speed. Fun fact, this runs at massive scale at Netflix. They have somewhere around 200 million users and 50,000 plus titles. Spotify does it has 100 million plus tracks. Steam has 70,000 plus games. Okay, so yeah. That's that. Sorry, my bad. I just love this tab thing on documents. That's why I'm totally doing it here. So yeah, moving further ahead, there are three types of now. Three types of filtering or items. Okay. Uh, Now the three types of filtering of items are, one is collaborative filtering, and then second is content-based filtering, and then hybrid ensemble. Okay. Uh, Probably let's just insert a table. Probably we should do this. Okay. Family, that's the core idea, and then works in what situation, and then probably fails when we don't need this. Okay. One is collaborative filtering. Okay. And then content-based filtering. And then hybrid ensemble. Okay. What is core idea? Users, like what is collaborative filtering is, okay, users that have agreed in the past will agree in the future. Okay, so this is just runs on a big assumption, like those users um, well done one thing, okay, they will also likely to do the second thing together again, or maybe if they have done randomly same things, like for example they have watched this Harry Potter movie, like there were three users who came in now. Okay, one was Niket, second was Roger, and third was Sam. Okay, Niket watched Harry Potter. Yes. Niket watched Home Alone. Yes. Niket watched Die Hard. Okay. Roger watched Harry Potter. Yes. Roger watched probably Home Alone. Roger watched The Dark Knight. Okay. The Dark Knight. Roger watched The Dark Knight. And then Sam was there. Sam watched James Bond movies. Sam watched Jason Bourne again. Jason Bourne. Okay. So yeah. Now these are three users. What will Niket get recommended? And then what will Roger get recommended? What will Niket see in his Instagram? Niket is most likely, we just saw that Niket is like, these are the two titles that are most likely to appear on Niket's screen. Let's just do one more title quickly. Okay, let's just say, one sec, we'll just put it here. Okay, now we are going to, sorry, we are going to put it here. Okay, maybe change the color slightly a bit. What should be color? Same yellow would work. Okay, now what we should do is um, probably guys, just FYI, if I watched any of another movie, for example, I saw an action movie, I saw Dark Knight, the score increases. Like Niket watches, Niket has saw. This score means right now how much movies Niket has seen of that hashtag or filter. Okay, so probably let's just say there is a James Bond movie, No Time to Die, or maybe Spectre, or maybe Skyfall. Okay, what are the hashtags? Action, yes. Robbery, guns, okay, cars, and then what else is there? Mm, is it a Christmas movie? No. What else do you want to do? Write under James Bond quickly? Maybe it's a blockbuster. Blockbuster you can always write under anything. Maybe spy. Yeah, spy is good. And then second is let's just not go into the fantasy realm more of what else do you want to show or watch. Let's just call Friends series. Okay, now let's add a Friends series, or maybe Hangover. Let's just say Hangover. Okay, James Bond. We are going to color it as purple and grayish. Okay, and the Hangover series is as um, now what do you say with Hangover? Comedy, yes. By the way, you could also had written comedy under Home Alone. We didn't write it under Home Alone. Should have. What should we do? Um, okay, let's just move on. Comedy, buddy. Okay, and then what else do we have with Hangover? Um, Drinks maybe? No, not drinks. What else? Comedy, buddy, mm, travel, yeah. And then, so, can you say boys movie? No, we've just written buddy, so it's good. What else shall we write under Hangover? Let's just not say anything. Just keep it like that. Um, what color do I want to give it? Blue. Blue is good. Um, okay. So what I should probably give it more. But what else is there? Animals, yeah. And then Mike Tyson was there. I'll ask Google. Give me 5 hashtags for hangover movie. No, but yeah, casino. So this is that. Now, um, if I have to see what is most likely movies that are going to show to the Niket. Okay, Niket loves Niket have seen Harry Potter. Niket have seen Home Alone. Niket have seen Die Hard. All these three movies Niket have seen. Okay, and this was the score of Niket. Okay, so based on those movies, let's just quickly also do the score of these movies. Um, this is right now for Niket, okay, not anybody else. This is right now for Niket. I will come on to like what is score of Roger and Sam and everybody. Let's just also do Rogers and I should have not done Hangover. Maybe we should call it Hangover. Sam loves Hangover. Okay. Sam loves Hangover. And then there is third movie, The Dark Knight. Okay. And The Dark Knight has action, robbery. What else is there? Guns, superhero. What else is there? Um, Maybe crime. Yeah, cool. Yeah, that is The Dark Knight. Should probably give it yellow and black. Okay. So what's the score of Dark Knight now for Niket or anybody else? Okay. We will come on to it. Shall we or not? Okay. Let's just count the score of the people as other people as well. Okay, Roger. Now, what does Roger like to do? Roger has seen Harry Potter, Home Alone, and The Dark Knight. Okay, so Roger's score is what is the most repeated hashtag that Roger we see with Roger? Christmas, most likely. Okay, so it is Christmas for Roger, and then robbery is also second there. Both are at score 2 and 2. Okay, and then what else is there for Roger? Um, quickly, guys, quickly. Ah, you gotta keep breaking your knuckles. And then Christmas, and then robbery. What else is there? We have robbery is done. Okay, he has remaining everything else is just one. Nothing else is common in Roger's pattern now. Maybe family. Yeah, family is twice. Okay. Um, kids is twice for Roger. Okay. Um, what else is there? Yeah, that's it. That's it. Then everything else is just 1 1 1 for Roger. Okay. And put action as one. Robbery is done. Superhero is one. Is crime done? Yeah, crime is done. Crime is one. Okay. Um, cozy is one for Roger, and so on. Everything else is 1 1 1 for him. Okay. Kids is one, 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 one. This is all for one for Roger. And Sam had just watched James Bond as well as Hangover. Nothing is common. Everything is just 1 1 1 for him. Okay. So Sam has all the score as one. If I just copy paste it for Sam, one, 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 one. Okay. This is for Sam now. Okay. Color change it to everything to black, and then probably give it some another pastel of yellow, and also give Sam some another pastel of yellow. Okay, so this is that now with all of them. Okay. Now coming on to the scorings of each. What does Nicate's score is likely happen in action category? So in this way, probably, if I just have to write, I'll just do it quickly for Niket and Roger. Okay, Niket's action score is 1. Okay, Niket likes robbery. 2. Niket likes guns. 1. Does Niket likes cars? No. 0. Does Niket like spy? No. Niket doesn't like spy. Okay. What about Hangover? Does Niket like comedy? I should have put in the comedy in Home Alone. No. Niket doesn't like Buddy. No. Niket likes travel movies. No. Niket likes animal. No. Casino. 0. Okay. Though I love Hangover. Should be a record. I love the movie Hangover. Okay. And then action for action. Yes. 1. Robbery. Does Niket like robbery? 2. Yes. And then what's the score of Niket for guns? 1. What's preference? Superhero 0 again. And then crime 1. Okay. What's the total here? Is 4. And what's the total here? 5. Okay. So this is now Niket's score. This is the machine calculating at the background. Show me the stuff. Okay, 4 and 5. So I'm going to be shown the movies in this category. First, it would be Grinch, then Alice in Wonderland, then James Bond, and then Dark Knight. And maybe in a very random suggestion, that category of random suggestions, Hangover would come up. Okay, I'm going to be shown movies like this. Now this guy Sam, Roger, sorry, Roger. How does Roger like the movies? What's Roger's score for Christmas? 2. And then what about family? 2. What about cozy? 1. And what about kids? 1 again. What about robbery? 2. And what about crime? Uh, crime 1 again. Okay, this is Roger now. And then what about magic? I've not written magic somewhere for Roger. Let's just say 0. And Roger seen magic. Yeah, Roger has seen magic. So probably 1 for Roger. So magic 1. What about kids? 1. Family 2. Then cozy 1. And then kids 1. Okay. What's the total of cringe? It is 9. The total of this, it is 6. Okay, it will be shown Grinch 1 and Alice in Wonderland 2, and then action movies 1, robbery 2, and then guns. What about guns? 1, and then cars. No, nobody likes cars. Spy, he doesn't like spy. Okay, what's his total now? Again 4, good. Okay. Um, I think I've written Good Hangover very separately. Does he like action? Yeah. Does he like robbery? 2. Yeah. Does he like guns? Yeah. Does he like superheroes? No. Does he like crime? Yeah. 5. So now he would be shown as Grinch 1, Alice in Wonderland 2, Dark Knight 3, James Bond 4, and then Hangover at the most random part. Okay. So these are now two users agreeing with each other. This is called collaborating filtering. ओके दैट दीज टू यूजर्स इन दोनों का पैटर्न ऑलमोस्ट सेम था हमने देखा these watched movies very separately but someone was sitting in India, someone was sitting in US or Europe. Okay, and now Sam and Niket watched movies at separate places but somehow their patterns matched. So now algorithm thinks maybe the next third or fourth or fifth movie that Niket will like, probably Sam would also like, or vice versa. Okay, so that is the point now that Sam is going to like it will show other people who like the same categories also watched. Now that category forms up here. You know, other people also watch this. This is that how category forms. Collaborating filtering. Okay. But it works with large user base. Okay, and we need implicit signals. Okay, fails when there are new users or new item. Probably you do not have a new data about the users. For example, if now I add a third person, his name is Dincome. Okay. Now this Dincome person is probably new. There is no score about anything. Everything is 000 for him. Okay. Everything is just 0000000 all of it. So algorithm would never know like what to suggest him. Algorithm would just function very randomly for him. Probably in the first play through or go through of the screen, he would see Dark Knight. At first, Hangover second, James Bond third, fourth, fifth, 6, 7, 8. But maybe this one can change when he reopens the app again, kills the app and reopens it. 1, 2, 3, 4, 5, 6, something like that, randomly, where it is totally random for him. Okay. So this is how the collaborating filtering works. Okay. Now there is a thing. Okay. Okay, bit of slightly change of things. Bit of change of things. I actually um, said it wrong. Collaborative filtering is based on the user behavior. Okay. Um, Also, this will. So whatever I just said all about this, the hashtags and everything, this is all called metadata, first of all. Okay. And this is all called instead content based filtering, because this was the all filters of the content. Like what was the content, movie content, like it was Christmassy on everything. Can you show Dark Knight movie on a Christmas to kids? No, probably not. Can you show James Bond movie to kids on a Christmas? No. Hangover movie? Definitely not to kids. Okay, somebody who has kids or like family or cozy, uh, this kind of preferences, you cannot show him a Hangover movie at all. Okay, so that's is content-based filtering. Okay, I'm going to recommend items similar to items like. Okay. And then um, which item metadata. Okay, there is niche taste to it. Okay, and when does it fail? When it fails when for example, now there are so many parts of Harry Potter movies, 8 parts of Harry Potter movies. Everything has almost the same hashtag. It will be most likely going to fail. With the James Bond again, same hashtag, same everything. Or maybe if I had done Jason Bourne, almost the same hashtags. Most likely the recommendation would fail. Content-based filtering would fail in this category. Like Jason Bourne has action, robbery, guns, cars, spy, everything all of same, probably most likely to fail. Or maybe the movie Dhurandhar, action, robbery, guns, car, spy, fail. And any other spy movie, Pathan, Jawan, or maybe Tiger, or what else spy movies are there? Everything, A Man from Uncle, one with Henry Cavill, um, and all of that would fail here. Okay, but if there is some another movie of Henry Cavill, for example, Superman, um, action, yes, robbery, yes, crime, yes, superhero, yes, voila. If you are watching Dark Knight, then yes, you are going to get recommended Superman movie. Okay, so that is that. But at that point, you will most least likely to get James Bond recommended. But you will get recommended because it has action, robbery, and guns. Okay, so you are going to get recommended. If you're watching Dark Knight, yes, you're going to get recommended the James Bond and also Jason Bourne. But now, between the priorities between Jason Bourne and James Bond are dependent upon how rich the metadata is. For example, JSON born on almost have same, JSON born almost have the same hashtags, everything. You can't complain. Same. So how do you differ? Like you have to be more specific about your movie's hashtag. So the person who is uploading this movie now, you have to tell him add maximum number of hashtags you can add about this movie. Only then the system would pick up. And that one differentiating is British and this is American. If they are just added American spy and for him British spy, then yes, this is how they are going to differ up. Okay. So this is when the content based filtering works fails. All content looks similar. Okay. Now what about collaborating filtering? Collaborative filtering is works when um, yes. Collaborating filtering works when like how users navigate in between the screens. Okay. For example, if there is a somebody watching who is watching like there is somebody who is watching Home Alone. Okay. Um, then he next saw another comedy movie. Maybe let's just say Hangover. Hangover is a comedy movie now. Okay. I should add probably hashtag comedy under it now. Okay. So he saw Home Alone. He saw next movie was comedy, or somebody saw Die Hard. Okay, he saw Die Hard, and the next movie he saw was Dark Knight. Okay, and then probably third movie was James Bond again, action movie, same action movie. It is recording right now. Okay, so what happens? We are not talking about these metadata hashtags right now. This is just only focus on the titles. Somebody saw Die Hard, Dark Knight, and then James Bond. Okay, and then a new user comes in. He saw Die Hard, Dark Knight in the same pattern. While I am sitting in India, the other person is sitting in the London or maybe Paris. Okay, now he saw Die Hard, he saw Dark Knight. What's the third movie he's going to get recommended? Obviously, James Bond. Forget all of these hashtags. This doesn't matter. Okay, these are not there now. Just titles. Like this is another system we are talking about. Like Harry Potter. Okay, The Dark Knight, and then Die Hard, and then probably Home Alone, Jason Bourne, and then Hangover. Okay, he saw Die Hard, he saw James Bond, and then Jason Bourne. What is the and then Dark Knight? Okay, this was what I first saw. Then this is what I second saw. This is what I third saw, and this is what I fourth saw. Okay, and then the new person comes in. He sees probably Die Hard first. Again, he sees Jason Bourne, and then he sees either one of those, either Dark Knight or either James Bond. What is the next movie is going to be recommended based upon, like for example, either one of those. Like if he chooses Dark Knight first, next movie is going to get recommended James Bond. If he chooses James Bond, then his next movie is going to get recommended is Dark Knight. But how? How? Good question. No, actually, sorry, wrong. This is just based on that. If he's copying my way, like what pathway I followed, he's going to get the same pathway permutation, the same combination. This is just based on combinations. There is nothing. based on permutation here. Like those who know difference between permutation and combination would know. Yeah. So this filtering is based on permutation and combination exactly. Okay, there is a one simple permutation function working where the arrangement matters. Now the person who is coming to watch um, this in one particular pattern, the permutation starts picking it up. Okay, and it will start recommending the second person the same movies. Even forget all of this. Um, Person comes to watch Die Hard, and I saw movies in this fashion. Okay, second person comes, he sees Dark Knight, and then second movie he will get recommended is watch Jason Bourne. Third movie James Bond. Fourth movie Die Hard. He will see the same pattern only. There is no another pattern, but it fails. You know, when there is a large user base, like for example, there is this another person who is doing it for 4 and then 3 and then 2 and then 1 and then 5 and then 6. Okay, and then there is 1, 2, 3, 4, 5, 6. Probably it would not know. Like now I come in and watch Die Hard. Okay, and then there is another person who is done 1 here, then 2, then 3, then 4, then 5, then 6. Okay, the machine gets confused now. Whom what should I show him? Like he sees Dark Knight, so he is going to follow this pattern and this pattern. Okay, we are here. But what's the next movie? Shall I show Jason Bourne or shall I show Home Alone to this person now? What shall I show? It will get confused. You know, there is nothing it can do. So this is how it fails. So which one is better out of these two? Which one is better? Obviously the hybrid. Mix everything. We try to mix everything. So blend collaborating plus context. Context aware is content based only. The metadata. Context aware signals. Metadata. Okay. I just got to show you an example. System use which type of filtering solely. No, I don't want to. Yeah, Reddit still does this collaborative filtering. Like like if you upvoted one product, it is more likely to show up, or you know it is not exactly based upon, like I just gave you a movie example. Okay, I just gave you the one example of a movie. Like you saw the movie and then you second movie, third movie, the other person is most likely to see that. But what if you didn't like that, you upvoted or downvoted that movie? Okay, it also got a record that if you upvoted that movie, all the upvoted of those movies, like how much upvoted it gets high up ranked. Okay, or the how downvoted that is, it gets lower ranked. So these two functions work together. Okay, and then second, early Amazon would also work in that way. Like you would buy one thing, like you bought a product. Okay, and then you bought second product, you bought third product. The other person would also see, that shopping feature, other people bought this with this. Like you bought mattress, you also bought a pillow. I would also see that other people's bought this pillow with this mattress or bed sheet. You know, same thing. That shopping apps feature, people bought this with this, comes from here, like collaborating filtering. Okay, but when Amazon shows like for example, you're buying some IKEA. Okay, so what are filters of a table? Like pure wood, easy to um, join, or easy to like build it, easy to build. Okay, 5-star rated, all of that stuff. And if I'm totally buying 5-star products or easy to build product, DIY products, easy to DIY, so probably it will be going to show me only DIY products, or in that way. Like he will note that Niket likes easy DIY, do it yourself, easy DIY. So I should show him the easiest DIYs only. So in that way, Amazon works in both ways. Hybrid example. With Spotify, it works like with Spotify, it works in the sense that probably with Spotify, like if you heard a song, if you upvoted it or downvoted it, how many times you heard it, if you really heard it like hundred of times, then how it saw the matlab, how well it read it. Okay, for example, there is some there was the song Despacito. Okay, I probably have heard 100 times the day it was released, the Despacito song. Okay, I was working in library and this was the only song on my Wi-Fi couldn't connect to the laptop, so this was the only song playing all and over again for me. So Despacito I heard hundred of the times. So what it tells it? Spanish song, yeah. Rap song, yeah. Okay, I also like the product, so yeah. Some scores for that, for liking the product. So my whole algorithm changed. Like it started suggesting me that as Spanish songs, like Lucy Fonsi, all of songs by Lucy Fonsi, all of that stuff. It showed me all of that, and then probably it also picked up like it would show me like people who reheard Despacito multiple times also heard this song. Let's say some Shakira song. She's all Spanish, so some Spanish, or maybe Enrique song, he's also Spanish, Bailando or anything. I actually got suggested Bailando. Um, so all of that stuff got recommended to you based on your patrons. Um, so I just quickly write it. So when does it fails? When it is poorly tuned, obviously. When the scoring system is not right. The scoring system, this one, and also the other scoring system based on recommendations. Like how much priority do you want to give to what recommendation system? If that fails, then your system fails. Poorly tuned. It's called weights. The priority is called weights, okay? Or contradictory signals. Come on, man. Okay. So we have to write. I'm just going to write a formula, okay? Nothing big. and probably skip it again. One is first you do data collection, then you do feature engineering, okay. Then you do model training, and then you do candidate generation, and then you do ranking, and then re-ranking, loop, okay, and then serving and A/B testing. Yeah, that's that. Okay. So, what is data collection? Data collection is again so data collection is like what happens in data collection. Capture plays, skips, ratings, dwell time. Key tools are like Kafka, Kinesis, Snowflow. Guys, who have worked with Kafka or Kinesis and everything? Apache Kafka, open source tool, just organize the data and save the data. That's it. Like I was doing it in Excel. It is like tabular form, stored in the tabular tables and everything. It's connected. It can be connected with NoSQL, Oracle, Hadoop data, all of that stuff. Kafka can just and then you can also attach microservices on top of it. I'm not going to all analytics and microservices. So Kafka is the base of all. It's like the base. Like you can just like the data storage. Kafka is the basic of the data storage, let's just say. Okay. The raw data that is there, that is all in the Kafka. You just throw it all of it in there and organize it and throw it on in the Kafka. Okay. And then same works with Kafka, Kinesis versus Snowflow. All of that stuff is same. So that is Kafka, and then Snowflow and Kinesis. Okay. And then what is feature engineering? What happens in feature? I should probably make table. Okay. Build embeddings. Connect the data to your build the app and then connect the data backend and everything. All of that stuff. Ratings, UI, and all of that stuff. Or maybe connect the tables and everything. Tools are probably Spark. If you are using Kafka, then Spark, you will use Apache Spark, okay. FAISS, DBT, all of that stuff. And then comes the part of model training. Train on collaborative filtering, content, filters, all of that stuff. Start creating all of that, okay. And if you are adding AI, then deep learning models, all of that stuff would come in. AI was probably nothing, just these like now the RAG has come, but before RAG, the AI was nothing but the suggestive tool. Like you had added this whole metadata here, and then AI was probably the ChatGPT thing was nothing but a better metadata to solve organize the data. For example, back in 2023, when you would ask it a joke, for example, suggest me joke on Christopher Nolan. Okay, the AI would create some pick up some Christopher Nolan joke from the biggest of the libraries that anywhere anyone had ever shared, and it had the probably tag of Christopher Nolan joke, so probably it will try to make up it. If it didn't had, what else you can associate with Christopher Nolan? So it would try to make up it. That's why the earlier AIs were so bad. Tools that you use are PyTorch, TensorFlow, and then MLflow, all of that stuff. Okay. And then candidate generation, obviously. I'm not going to explain what is candidate generation. Okay. And then tools. But do you know what is all of these tools that I'm writing? Let's learn it together. Facebook AI similarity search, open source library built by Meta for fast similar search and clustering of high dimensional tensor vector. Okay. And then scan scalable nearest neighbors for again for collaborating searching. FAISS is by Facebook, and then ScaNN is by Google. Research, is again suggest you the next, you know, it is going to suggest you the next, probably the recommendation or anything that it want to. ANN here meant the same, approximate nearest neighbor. Okay. So approximate nearest neighbor. Rough data approximately you require some 1,000 candidates or items for it, and it can provide 100k recommendation just combinations accordingly. Okay, pine cone is again there is universal database. Who created it? Nobody. It's a private. Okay, and then probably ranking and re-ranking loop, score items. Okay, or if there is any diversity rules, for example, child product of that meta one hashtag, something like, for example, within family comes babies and everything, all of that stuff. Or maybe like if it's a below 18 account, do not suggest particular metadata to it. Do not suggest particular combination of visiting or navigation to it. Collaborating. We use XGBoost, LambdaMART, all of that stuff. Highly optimized open source library implementing gradient boost decision trees. These are all again decision trees. Okay, and then within serving and serving and real API, experiment, routing, fallback, chain, all of that comes in. Cell done, then to ML, optimizely, all of that stuff. It's just an A/B testing tool. Those who don't know, A/B testing tool is like it will give you data, it will read and record. Like you just cannot sit all the time and watch thousands of users, 100K of users go through the data and stuff. So it will give you the proper data. Like, hey, while you were sleeping, this happened. Like this was the most popular um, pathway user saw, or this was the most popular movie that users saw, and these were the hundreds of choices people actually saw, and the top 10 were these, and the top 100 was that. So it will give you the summary of it. It is a tool to just give you overall experience, real time data or the charts. Okay. Talking like my throat sits down. You should think why it exists. The quickest answer is to enhance the user experience, obviously. Why it exists? Back in 1994, when the usernet was the only thing of internet, there were too many posts. Everybody was just posting on internet. Too many posts to read. Um, the first collaborating function was then published at that time. If I'm somebody is reading this paper and this paper, he should get also the other person, if he follows in my footsteps, he should also continue following in my footsteps. That was the first ever paper about this thing. Okay. Then Amazon came in 2000, millions of products, but staff couldn't curate multiples of pathways. Back at that time, you had to write code for every single thing. You know, Item to item collaborative filter. So that was it was born. Like somebody suggested, why don't you use metadata? For example, back at that time, Amazon was doing books. So if you're reading a book, for example, Harry Potter book, magical book, kids book, everything. What's the next book you should be suggested? Maybe Alice in Wonderland, magical book, fantasy book, Lords of the Rings, maybe fantasy book, another fantasy book, all of that stuff. But you should not be suggested crime books or self-help books because you are interested in the magical books. Your filter would just fill up with magical books. And then they improved it further ahead. They added also added, then it formed up to form like the they diversified the metadata. Like Harry Potter has friendships as well, so more friendship-based movies, maybe Hangover and everything. Not Hangover, sorry. What was the name of the movie with Jennifer Lawrence? Hunger Games? Maze Runner, yeah. It's also about friendships and everything, you know. Or maybe Annie Debleton books, all of that stuff, you know. So Annie Debleton books, they were all about friendships and everything. Tom Sawyer and Huckleberry Finn, friendship again, friendship book, sorry. So all of that stuff came into Amazon, and then Netflix came in 2006. They even had 1 million prize to beat their recommendation algorithm. Like they had whole metrics factorization. Um, like the enhanced content, filtering. Then in 2012, YouTube had a very big problem that there was a boom in people uploading their free videos, but despite that, they had a very less watch time. So, they implemented the more deep neural network, more metadata was added and everything, based on that metadata, weights came into the picture, weighting and everything, you know. And then by 2016, TikTok came into the picture. Um, you know, there was like no, they totally removed that like or dislike feature. It was purely a totally new form of, you know, recommendation algorithm because they had just very diversified the metadata that had to be shown. They mixed everything. Like they one post would be shown based on your highest priority metadata, and then next post would be shown on based on your second highest priority metadata. Third post, we're talking about metadata, I'm talking about hashtags here, okay. And then third post may be based on your collaborating filtering, like if you saw reel 1, reel 2, another person also saw reel 1, reel 2. For example, one was dog reel, second was dog reel again, dog pooping reel, maybe dog playing reel, okay, or dog barking reel, okay, dog and then barking, and then third person saw cat reel. Probably you will also like a cat reel. So yeah, it showed your cat reel. But what happens if your cat was your most disliking, like disliked? So it will weigh accordingly if it wants to show you cat reel or not. So the TikTok like mastered it and everybody's tried to copy it. You know. Why it exists? I just gave you the history. Okay, history lesson. And then second is um, business case about it. So what was the business case? For Netflix, it worked as in 80% of hours watched driven by recommendations, and then for Amazon, 35% of GMV attributed to Algo engine. Same goes for Spotify. Don't come to Steam. Steam has very bad still, like they had to engineer it so far. 40% off streams sourced via Discover Wiki and Algo playlist. Okay, so that's that. And what else do we want? Like without this, like totally algorithm recommendation engine, user would face a decision paralysis. That is actually true. They will open an app, they will see a totally random suggestion all the time. Imagine a kid opens the app and he sees probably some art movies. Would he want to watch that? Maybe 60% or 70% no. Uh, 30% chance, maybe yes, if he's an art student or he likes those kind of movies. But maybe he will drop the from. Most likely he will drop off. Okay. So now we come into that. How do you design such an algorithm? You know, designing of that. Algo from scratch. So here we are designing an rec algorithm from scratch. Okay. First of all, before even writing one single line of code, first of all, think what is your North Star metric? Like, what is the one thing that you want to aim for? Only then you can put the weights everywhere. Like these hashtags would come up. You can maybe employ a kid intern, okay, and then tell him that okay, write hashtags for each movies and everything, create a raw data for you for each movies and everything. That doesn't matter. Just add now what of those weights you want to prioritize heavily and what of those weights you want to negate. For example, Netflix prioritizes watch hours. Okay, how many hours you watch? Like, what's your engagement rate with the movie? Okay. Spotify for the streams per session. You know, Steam, the game aggregator, for the purchase conversion. It its sole goal is like it should you should it should everything should increase the purchase conversion. Like you saw a game, you should be compelled enough to buy it. Okay, Netflix is like you have already paid, but you have to maximize the watching hours. Okay, so that metric shapes every significant decision about it. Okay, for example, guys, I'm going to take a break. Yeah. So, for example, we were talking about how Netflix or any Prime Video kind of like streaming service, um, their sole goal is to increase their watch hours. But how watch hours is, connected with the biggest of all revenue, or all of these smallest of the like recommendations and everything maximize helps to increase the watch hours. Okay, for example, take a very clear example. If you land onto Netflix, you may or may not see. Let's imagine that there is no recommendation algorithm working on Netflix right now. Okay, so what happens? You may or may not see or come across your favorite movie that is there. Okay, probably if there is no recommendation algorithm, probably there could be two things now. Either a random function is working, you will see the movies randomly. Every time you refresh, the whole page refreshes, and the random function totally. You cannot imagine like what movie is gonna show up at what time. No control over it. Okay. Maybe also it can happen. There is a huge risk to it that we will come on to the risk part. Or like one is random and the second is first in first out, or last in first out, something like that. Like the movies that have been adding, piling up on the list, the last one that was added, it would show up on the top, and the first one ever that was added, it would never show up because with time you will start pouring up over the movies on top of it, and then you can just watch the latest of the movies. What movies are being aggregated in this latest one? Probably yes. um, can you find the first ever movie? You will have to scroll really, really, really downwards. But because you cannot just search it out like what was the first movie ever added on Netflix, you cannot do that. So there has to be something that actually prioritizes the movies. Now, within these, there is a heavy risk to it. Um, for example, there is a kid watching, and it starts suggesting 18 plus movies, A plus A graded movies, all of that stuff, adult movies. Would you want your child to be on this such kind of platform? Or for example, if you want to watch, oh sorry, it is connected now. It should work properly. Is it working? Yeah, it is working now. So what happens if there is a movie that is like 18 plus, you would not want to watch it. For example, now if these two functions are there, you come onto the platform and you watch the movie. Then what happens? Maybe you will watch it one time, you will watch it second time, but how would you maximize it for the watch hours? Maybe you, first of all, um, add a continue watching function. Probably yes. Okay. Add a continue watching function, and then add similar such movies so that you want the users to be sticked. For example, if person who loves magical movies, it is a Christmas time, everybody wants to do Christmassy thing. You would want to watch the whole Harry Potter marathon. And what if there is no recommendation algorithm to it? Um, Probably, the whole UI is like, because you see all of these systems that are designed, these app systems, they are designed in such a way that it universally accumulates all the movies or the items that is going to aggregate. And somebody in some corner of the world is thinking all of that, like what general feeling or what general thought process of people is about those movies. For example, you cannot just share Harry Potter and then manually convert Harry Potter into 8-part series. Okay, if your first idea was that hey, convert Harry Potter into 8-part series, then why not? Maybe people would come and watch it, Harry Potter. you know what about if there is someone decides to add a fan fiction, or what about like how do you associate Fantastic Beasts movie to Harry Potter world now? Okay, you will say, hey, create again the space for another 4 parts or 5 parts. Great thing. So this is what I would do for the rest of my life. Like whenever the Harry Potter movie is added, I would just wait and code the next part to it. And probably how many movies would be such in like in that world? Like right now it is Harry Potter, then there is James Bond, then there is Lord of the Rings, and Lord of the Rings have a different uh, two types of different trilogies. One is Lord of Rings and then Hobbit, and now there is another whole series, Rings of Power, that's whole series. So is this my only job in the world now? Or maybe I should think of a generalized solution to everything, so that people can actually watch something similar. Okay, so if I add a hashtag of Harry Potter, magic, cozy, family, friendship, probably, and higher up my chances. Like a Harry Potter is my highest chance. Now if I'm watching Harry Potter, I will get recommended of all the movies hashtagged with Harry Potter. Okay, and probably you can also add the hashtag of Harry Potter, or maybe hashtag of Dumbledore or Hogwarts in both the movies, because it was a common link between those. So magic and everything. The more number of hashtags being increased, the more chances of being matched with those movies. The metadata you uh, write about in more brief, the more chances that you are going to get like it. And then second one is, we're still not being able like decide what to watch after Harry Potter. You know, like you have to watch the all 8 parts. Now you're having this feeling, what do I do with my life? Like my life is over. Probably now collaborating filter wakes up at this point. You know, collaborative filter thinks this person watched Harry Potter. Maybe I should suggest him a pathway that other people took. They saw 8 parts of Harry Potter, and then maybe they switched to some, Alice in Wonderland, or Charlie and the Chocolate Factory, all of that movies. Probably that. So this is this is their way of keeping you hooked to the app screen. Like you spend 3 hours, maybe watch this movie and spend good another 3 hours with us. and then maybe 3 further hours with us again, all of that stuff. So probably if we talk about same goes with music, active streams and everything, and so like that only. I'll just quickly add a table. Okay, if I just quickly add a table here, it's a platform type, and then primary objective, and then proxy signal, and then anti-objective or vain objective. Let's just call it vain objective. Like it's like a proxy thing that you would want to avoid. Like it looks all shimmery and glittery, but you would want to avoid it. That's the thing with that. So first is streaming. Okay. Next is music. Third is game store. And last is maybe let's do one for e-commerce. Okay. So what do you want to maximize in your product watch hours? What do you want to maximize in here? Streaming time. What do you want to watch in purchase and maybe playtime too? Okay. Um, Lifetime value or GMV? Probably yeah. Um, Proxy signal that your watch hours is working. What's a direct metric that you want to see? Or completion. Yes, like person is watching all of these movies. Probably skip rate is less than 50 seconds, and somebody added into wish list to buy purchase rate. Okay, and then add to cart or repurchase. Okay, for all of this stuff. Anti-objectives to avoid, vain objectives to avoid. Clickbaits, thumbnails, that means low completion. Okay, and then autoplay loops, stale, null, and then pure sales rank always. Okay, so what happens is if probably I want to really get a small greater. So these are the anti-objectives to avoid. So first step is actually I just should have written define your objective. Okay, so this should be the one. Define your objective, and then second is collect and engineer signals. Um, I'm just working. I'm so sleepy, guys. I'm so sleepy right now. Four table is good. I just say signal type, and then examples, and then strength, and then lag. So these are the major signals that you would want to add in your product. Okay, and then what is social? Star ratings, you know, thumbs, and then what is the review? Okay, we are just taking example of Netflix here. Okay, only Netflix or we Prime or streaming करते. Um, like how accurate it is. Like what's the strength of it? Like you know, what's its impact? Strength can be measured in what's its impact, how accurate it is, you know, and impact as in like how the users would perceive it. You know. So there is a high accuracy and it is sparse. Okay. How much time do you think it takes up? Uh, Hours to days. Like people would just add reviews after watching a movie. They would take reviews like after a week or maybe or something. If you prompted that much to them, they will. If you know you do not, but you do not also want to come as annoying. Implicit positive. Implicit positive. Okay. So what is implicit positive? Like what's a positive signal that people are liking your movie? Okay, irrespective of if how rated it is. For example, there can be a brain rot comedy that was badly rated by one certain section of people, but other section of people loved it. They are playing it. So that's so, but this another section who loved it did rate it, but they love and they played it. You know, sometimes on Netflix there are some series which are due to be removed. Like it has already written that it will be removed within a week or by the end of the month. There are some series or movies, and then you start watching it and sometimes what happens is that movie is not deleted after that month. They just remove the message. Or sometimes what happens is they bring that movie after a month or so. So you know, these are some implicit signals they have. Like these signals means that uh, the series didn't had good rating, or maybe it didn't had good thumbs up or reviews, but still people liked it, and so they had to bring it back. So those kind of movies, and one of the biggest is play. Explicit is people based, how people are reacting it, or most likely after purchase. Okay, after purchase, implicit most of the times, and then it is play, purchase, maybe long run. And implicit is like people are actually watching it. You can fake the explicit. You can always fake the reviews and everything, but you cannot fake the implicit in the longer run. It filters out, like if people are actually loving the movie or not. It was all just fake reviews and everything. So implicit is also there. Okay. Rotten Tomatoes is probably, has been serving as a bad aggregator of movies so far. Like it has allowed everyone, and people are actually manipulating the whole reviews and series and thumb lists. So explicitly, it is kind of like bad. It is functioning in bad faith. They got to do they have to like check out the implicit metrics, but there is no way Rotten Tomatoes is a streaming service right now, so they cannot like check totally the implicit reviews, implicit signal types. For example, the difference between Rotten Tomatoes and everything. Um, Rotten Tomatoes and Prime Video. What's the difference between the both? This has implicit signals, you know, like sorry, this has explicit and this has implicit. This has explicit like likes, ratings, reviews, and everything. Okay, Rotten Tomatoes has that. They have the play signals, rewatch. Okay, and then maybe what else? Trailer. Okay, um, trivia signals. I don't think they do trivia anymore. What else is there? Wish lists, all of that stuff they have. Theirs is my like 50% accurate. Rotten Tomatoes have. Okay, so both are equally functional, both are equally educational to work together, but individually both can be faked. You know, implicit signals. You can start a movie, watch a bit of it, you can get bored and then drop off. It can be good. It would be like considered as +1 score for playing. Okay, but or maybe you can wishlist a movie, but um, you would never watch it. It can be considered as an implicit signal. But would that make a movie great movie? Probably not. Like some of the movies, like bloated, really movies these days, so-called blockbusters, are heavily um, like published or pushed, and maybe for example, think of any Marvel series that became flop. Okay, for example, She-Hulk, or maybe Wonder Man. All of these series. Not I do not have any personal thought to it, but people actually loved saw that, oh, She-Hulk character, we are really big fan of it, we would watch it. Maybe people dropped off after one episode or something or so. People were like, nah, it's not for us, and they dropped off. you know they wishlisted it, the trailer, watched the trailers and everything. They then saw the first episode, and then they were like, no, we are good, we do not want to watch it. Or maybe the Suits LA, with Oliver Queen actor, Arrow actor. Um, so people saw that, oh, great actor, and kick-ass series they had done. But when they saw the first two episodes, they were like, "Nah, we are done," and the series never got renewed. So in this case, in case of Suits, Prime Video failed. Okay, in case of Suits or She-Hulk failed, helped. In case of Suits, helped. Suggest me some movie that had very bad ratings, but people actually liked it. That was panned by critics. Um, Maybe Deadpool and Wolverine. Big Trouble in Little China. All of these movies. Assault on Precinct 13, all of that. Maybe Deadpool and Wolverine movie. Any Marvel movie. Only it is panned by critics. Failed. Worked. So in this way, you can always think of it. So probably the strength is dense, and it can be slightly noisy too. You cannot actually concur that if people watched it. You can probably sleep through the whole movie. You can find it boring and sleep through the whole movie. So it is slightly noisy in that way. But you will always get a real time data. Implicit negative, skips, and then less than 30 seconds watch time or listening time. Device location. How is location connected? Good question. Um, Often ignored. How is location connected? Okay. What is implicit negative signal? Can skip the movie? Probably yes. Okay. You started a movie and then you dropped off. Or maybe started skipping the episodes. All of that stuff. Or maybe you were watching a movie and then you picked up the marker and dragged till the climax. You know, or maybe there are some people who watch a 3 hour movie within half an hour. They just really fast forward everything. Yeah. So so these kind of are kind of implicit negatives. Tells you about your content. And second is device based. So what happens? Like if for example, a Christopher Nolan movie is being watched on a phone. How's that? You know, maybe or maybe not. It will give you good experience or not. It actually works with the games. If a game is meant to be played on a console for a better experience, best experience, and still it is being played on phone, maybe it will not give you a good experience. People would churn away. People would be like, "Hey, what is this shit of game? I don't want to play it." So they would churn off. Just imagine somebody is playing God of War on their phone. You know, Mm, it is meant for consoles. Actually, it is meant for PlayStation only. The PlayStation handheld controllers and vibrators, all of that. You can actually feel the pain of the game. But shifted to like a phone, it is like another hack and slash game. And solving and puzzle and everything. Maybe people will not like it, or PC players probably but PC players are never biased. I feel so. Okay. So then it is actually very valuable. And then same goes with the location as well. For example, if there is a Russian song being played in India, why it is being played in India? You would want to question it, you know. Or maybe um, means non-native songs is being played or something like that. I cannot associate with any game example right now, but maybe something like that, like a Chinese movie is being played in non-Chinese speaking country. Probably you would want to see that signal, like why it is happening, and then it is being dropped off. Then obviously you would want to, like, you would know your user story, that somebody played a Chinese movie in America or in Europe, and your user was had chosen the system language as English. Then why would he want to watch a Chinese movie? He will drop off. And you cannot just think that this was a bad movie. No, um, you will think of it as like it was a wrong match, something like that. You will always see real time, and then contextual. Again, time of the day, device. Look, actually, it is contextual. It all comes under contextual. I want to change it. Scroll past. Actually, that why I was also confused. So implicit negative is kind of easy to understand. Skip, or maybe song skip within 30 seconds. Scroll past, or maybe not interested buttons. All of that implicit negatives. But contextual is now the thing that I was talking about. Somebody is watching Chinese movie in from an account where he has chosen the system language as English. Why would he want to see that? Or maybe the device thing, device works with games and everything. Like, what is the context of the game? For example, there is a game, VR headset game, and somebody is playing it in phone or maybe a PC. Would that make sense for them? you know no, probably not. Probably it would, for them it would be a boring game, something like that. So yeah, it's a modifier signal. Again, it's a real-time data. And then social. You probably already know. Friends, likes, share actions, all of that. Watch party that you create, or like outward URLs that you create, all of that stuff. Powerful for discovery. And it comes within minutes, that is data. Just FYI, if you're still designing it, um, implicit negative is actually the most underused data so far I have seen in the companies or boardrooms. Everybody just like, you know, maybe maximize on the play movies, purchase movie, long devel, all of that stuff. Or maybe highly rated movies maximize onto that, thumbs, and nobody wants to dwell. Nobody has a time to just dwell into what actually happened wrong with the movie or something. Something is not working. Everybody's like, just remove it. Nobody wants to think like something algo is not working properly. In that case, if algorithm is failing you, and you can actually save a lot of um, energy or resources by just changing a bit of algorithm. So implicit negative is like a highly underused signal that is there. This actually reveals what a user doesn't want with an extremely low friction. What is expectations of uh, low friction, or like a expectation of the movie friction. Build third is build item and user representations. Probably, if you are technical, you will now understand and you have understood maths. This is for machine learning folks now. Okay. Uh, I just say if I want to simplify it or not. Okay. Representation and then method and then dimensions and then update frequency. User embedding, metrics, factorization, you know. CF. What did CF mean, guys? I'm not going to tell you again. Okay. Neutral CF, user embedding. Item embedding. What to back. Okay, just talking about these two first, user embedding and item embedding. Then there is session embedding and context embedding. Okay. Um, what is user embedding? Let's Google it first. And then what is item embedding? Got it. Okay. So user embedding was when I told you here, like what did Niket like? Niket like Christmas, function, cozy, robbery, magic, crime, guns, action. What did Sam like? Christmas, family, cozy, robbery, magic, crime, guns, action. What did Roger like? Robbery, crime, Christmas. Dinkum like Christmas, robbery, action, gun, superhero, cozy, magic, all of this stuff. Okay. Now it connects me to Roger, Sam, Dinkum. Okay. It doesn't connect me who doesn't like Christmas, or maybe who chooses adult movies, something like that, or art movies. It doesn't connect me to them. It connects me to like forms a chart. Niket connects with Roger, Niket connects with Dinkum and everybody. So, just to picture what is matrix factorization, well studied maths would understand. Now this is Niket's matrix, for example. Consider this is Niket's matrix. Okay. Now Nicaid's matrix can be divided into two parts. Okay. Um, one is this one matrix is like Nicaid has a personality of family oriented movies. And this one says Nicaid has a property of fantasy movies, fantasy. So family or within for a family oriented movies, it will show me other family oriented movies, you know, all about It's a Beautiful Life, all of that stuff. Movies comes into family oriented movies. It's a Beautiful Life, or Stuart Little, or anything else that comes under there. And then fantasy movies, all of that stuff, Lord of the Rings, even superhero movies, because that they also come under the fantasy section. So all of that superhero movies. So I divided my personality into two properties. Niket likes family, and then Niket likes superhero. Okay. So now it connects me to other people. Like it would suggest me some of the fantasy movies, or also some of the family movies. Okay. Um, but also like my based on these two of my personalities, I would get recommendation from other people. Okay. So I'm just showing you both the item embedding and as well as metrics embedding. Okay. So probably if Niket like this, then Niket would like that. If Niket like this, then uh, you would also like that. Something like that. Okay. Niket liked Harry Potter. Niket liked um, Grinch. Okay. And then Niket liked Alice in Wonderland. So Niket likes magic and kids movie, Christmas and kids movie, and magic and kids movies. All of that stuff and family movies. Okay. So Niket likes these kind of movies. So probably it is going to suggest me movies accordingly. And then Roger comes in. Roger will see, oh hey, this is that. Basically, user embedding is nothing but CF, or the CF I said. What is CF? Those who know. No. Collaborative. Okay. User embedding is nothing but collaborating filtering. Okay. Item embedding is contextual filtering. Word to or everything. Word to back on metadata, watch co-occurrence, everything. That is item embedding. You can also hear watch. You can check out for 64 to 512D. Okay. Whenever in doubt, just pick up that word and Google it. Yeah, that's that. Okay. And then session embedding. Guys, I for the sake of time, I'm going to skip why dimensions are particularly this because that's a whole another topic. Those who want to study can just take a screenshot of it and ask ChatGPT why did he write that. Okay, give the context to ChatGPT. Cool. And then this is context embedding in one hot learned lookup table, item embedding. If we had to go like within this, the whole definitions and everything. If item embedding is all about that, then session embedding is all about, how was your particular session in the app or screen, like how much time did you spend watching trailers and everything, like how much time did you spend on a screen, your whole metrics is being tracked. And then context embedding is, you know, representation of external factors like time of the day, device type, and everything, or weather. It captures the current situation. Like, for example, you're listening to some podcast at the night, so they are gonna form a new category now. Like every night, you will get a new notification. It's a night time. You want to maybe listen to these kind of podcasts further at crime. For example, you have a knack for horror podcast listening at night. They're going to ask you next time. If you will form the data, they will notice it. Candidate generation. Sorry. Okay. But now the biggest catch of all is when I said that Netflix has like around 50, more than 50K movies titles. Steam has, a lot of these big titles. So, the catch is in them is, where did I write that? Yeah, here, earlier. Like Netflix has 200 million users, massive scale. And then 15,000 titles, Spotify has 100 million songs and 70,000 games. So you cannot now you know, increase the hashtags of each movie every time. You just decide that hey, we need a new quality line of hashtags. We should probably do it, and then you would go sit and then again start adding hashtags for each movie. For example, there was an actor who played side lead for lot of movies. Like he was a side actor in lot of movies. Um, he was just a side, standing hero or passing by actor in movies. But later on, he got very famous, and then people noticed him that hey, he has done so many movies. So people went on to watch all those previous movies of his again to just get a glimpse of his. But now the product manager cannot just go to all those previous movies and add the hashtag of that actors that this actor is in this movies as well. You know, so you cannot go and do that all the time. So how do you beat that stuff now? Okay, that is a problem statement. So at that point, you cannot score all the n items, you know, for every user at request time. So what do you do? Um, so what do is like you use the function of approximate nearest neighbor, like with the collaborative filtering we saw, like there is some user who is who has requested to watch that actor's movie, and that actor is now a big star. Okay, so you will find out. Like who were the other people who saw such kind of movies? Like let's just say that actor's name was some something Tommy Versti maybe. Okay, so you will for Tommy Versti. Okay, let's just take an example of Killian Murphy. Okay, Killian, before he became an overnight sensation with Tommy Shelby, he was he was doing small roles in Christopher Nolan movies. He was doing small roles here and there, all of that stuff. Okay, but the day he became a bigger star, people recognized him and went back to watch his older movies, like 28 Days Later or any other movie. All of that stuff, they watched again and again. So, but people found out, like those who knew, they found out about these movies from Reddit or anywhere, and then they searched that movie and watched it. Okay, and the ANN notated that okay, maybe this can be a potential sequence. But now, when you went to watch Killian's movies, okay, you were like, what shall I watch next of Killian? And it spotted it and picked up that potential saved ANN relationship and suggested you, hey, do you want to maybe watch this another Killian Murphy's movie? People like you watched it, you know. So maybe yes, people would watch it. So that's the stuff. So they use tools like I just showed you, FAISS or SCAN. FAISS is by Meta, SCAN is by Google, to form the pine coat or V weight, all of that. Do you want me to show you FAISS again? Um, it's complex, guys. Those who want to study FAISS can study FAISS or SCAN by themselves. I don't want to go into it. And then last, this one is step five is, I think you are really going to love it, Robert. No, this is not that. Um, Again, step five is something technical. Okay, it's called ranking. So how do you do ranking? Um, Use a ranking model basically. Okay, so you do ranking models, LambdaMART, wide and deep. Pairwise, interpretable, interpretable, and then normalization, plus generalization. Okay, large spaces. To tower neutral. Guys, we will study together. I am not also aware of all of this stuff. Okay, I'm just writing it right now. Or maybe shall we do it later on? I'll just write the names and study it, and then I'll mention the type and everything by the information that I will get. That is a better idea. Okay. So what is LambdaMART? Let's study. Learning to rank combination. Google uses LambdaMART. Okay. Hey guys, bro, explain everything as a layman. I don't know what to say. Lambda was okay. I have just understood what is LambdaMART and what is wide deep. LambdaMART was purely score based, like how I showed you score based movies and everything. Okay, it worked before 2016 and everything. Before TikTok came into the picture with wide and deep. Okay, before that it was totally lambda based. Everything was being scored. Like this guy is likes Christmas. Yes, so show him more Christmas movies on highest priority. Or maybe this guy likes family. And show him more. Then at second place, show him family movies. At third place, show him cozy movies, ranked cozy movies, scored or ranked cozy movies. It's strictly was score based. You could add as much as scoring logic to behind it. Maybe show three of the top scored movies and then mix it with the second scored movies, and then maybe uh, keep the sixth one lowly scored movies, seventh scored movies, something like that. So it was lambda was totally score based. Okay. Was it accurate? Somewhat. Okay. But then came wide and deep. Okay. Somebody decided to mix both collaborative and item context filtering together. Okay. So with collaborative came, if Niket is funny, Niket likes this movie, Dune. Okay, Niket likes Interstellar. Like this is talked about here. Niket likes Interstellar, space, spy-fi, which means if Niket likes Dune 2, Interstellar, Arrival, these three movies, it means it categorized as the Niket likes space, sci-fi, slow, philosophical, and visual movies. Okay, and then also maybe Chris Nolan movies. Niket watched Prestige, and then everything. Niket watched Dark Knight, and then maybe it is also gonna suggest me Dune 3, even if Dune 3 was badly rated or not. Okay, it is going to suggest me Dune 3 in that way. And if I also watch Dune 3, okay, I know irrespective of I watch or do not watch Dune 3, it is gonna see a pattern that if you watch Dune 2 and Interstellar, maybe you are on Niket's pathway. Okay, it mixed collaborative, it is also looking at my pathway and as well as your pathway. Okay, maybe you can also like the contextual items that Niket liked, you can also see Niket's contextual filters. So it is gonna show you some of my recommended movies that I got recommended. It is gonna show you the same. So this is wide and deep. Okay, now we head on to the two tar. Okay, now two tar neural network comes in. But the uh, problem with wide and deep is can it compare me all the movies all the time, like like probably Dune 3 would have like Dune 3 is competing against several of the movies to be recommended in front of me. Okay, there is Dune 3, there would be some Indian movie, Indian Galaxy movie, there would be Star Wars, again space, philosophical movie, maybe Mauritian, Project Hail Mary, all of that stuff. All of them are competing with each other. Which one do they want to recommend me? Because there is only one slot. So can it compare with all the movies in the world? Right now, I've just named only 4 or 5 movies. By next year, there would be more 4 or 5 movies, 10 movies. By next year, 15, 20, 25, all of that stuff. Can it compare all the time? And mind you, I'm not the only single person who is using Netflix. Millions of people are using Netflix. Can it do it for everyone? Duh. No. So the two-tower neural network came into the picture. Okay. So two-tower is was made for to work at scale. Okay. Then came into the picture of two tar. Okay, in one tar he kept all the users. In another tar he kept all the items, movies, games, or songs, and everything. Okay, then this two tar tried to assign coordinates to me. For example, if he sees that I like, I watched Interstellar or Dune 2 and Dune 3. Okay, it uh, gave me some score numbers. Okay, it gave me some scores like this one. It gave me some scores. Okay, and it gave me scores, and the total of my score was for say 15. Okay, it gave me the score, one particular kind of score, or maybe a very complex. He assigned me a complex code that goes Christmas, like CX for Christmas, CX, and against Nikedit he has written CX, comma F for fantasy, comma action A. Okay, he wrote this code. Now, probably now he will go into his second tower. Okay, and this within this second tower, he'll again check like what movie such movies I had given Niket to Niket. I will show you. This is paint. Okay. Now he writes against Niket as CX. Okay. Let's just say CX raised to power 3. Okay. Into fantasy raised to power 2. Okay. And then last is what did I write? Action. Okay. Action raised to power 1. Okay, this is my scoring. He assigned me this score. Okay, now he jumps on to the another tower. This is tower 1. Okay, this whole is tower 1. This is tower 1. Now he goes to tower 2. Okay, this tower 2 was a very big cupboard. Now within this cupboard, he will first go into his big cupboard. Okay, first he will see where is CX. He will go into the CX section of his cupboard. Okay, and then within that CS section, he will see uh, what are some F categories or what are some A categories. Okay, what was some F or A categories? Is there anything, any item on the shelf for me or not in the A categories or F categories? If yes, he picks me up and brings to me, and then he picks both of them and decides which one to show to me, if this one is cancelled or not, and he shows it one to me. Okay, this is tutor. Okay, how is tutor different from wide and deep? Wide and deep was totally based on scoring system and recommendation algorithms. Okay, it is exactly not going to fetch the real metadata at this moment. It's not reading the whole hashtag this, hashtag Christmas or everything, It is actually reading the smaller codes now. These are the small codes, and it is reading these small codes instead. It is not reading the full Christmas, it is not reading the full fantasy or Harry Potter movies and everything. He would have some code for Harry Potter movie, like for example, for a Harry Potter movie, he would have just HP 0000 um, Philosopher's Stone 1. This is the code. Okay, and then for second HP 000 Chamber of Secrets. Okay, now, first of all, if he sees that Niket likes HP movies, he is going to go running into the HP cupboard. Okay. and then within those, or maybe fantasy board. For example, this HP probably has this function F against it, and then CX, all of that against it. Okay, so he will go on to study first CX cupboard, he will go into CX cupboard, then fantasy cupboard. Okay, within that fantasy, he will see HP cupboards. He will bring one HP. He will shortlist one HP to show to me. Okay, then can he find another HP movie? He will see that Niket has already seen. Then he will close his HP cupboard and then maybe look somewhere else in his F cupboard, maybe Superman, maybe The Mask, maybe Lord of the Rings, all of that stuff. So that's how it is all embedded now, rather than giving proper names. Embedded codes uses less memory than the exactly proper names. Harry Potter and the Chamber of the Secrets, Harry Potter and the Goblet of Fire, you know, all of that stuff. Maybe a smaller code would be an easier one. Harry Potter and the Goblet of Fire, hashtag Harry Potter, hashtag fantasy, hashtag Christmas, hashtag, all of that, hundred of hashtags below that. You don't want to do it. Maybe you will just arrange it. Two Towers had just arranged it, everything. Just arrange properly in the way. Okay. But then again, Two Tower is not successful. Still you feel like there is something wrong with Two Tower. It cannot just work properly. Is somewhat similar to wide and deep. Totally agree with it. Okay. So now comes the fourth of the transformer cross encoder. Okay. Ministry, description, actor, genres, director, name, keywords, reviews. Okay. Okay. Got it. So now cross encoder comes in. Okay. Now cross encoder is like it will see what do you actually like in that movie. Okay. Cross encoder is not something that fastens the speed. It actually goes more deeper into it. Okay. In this category, we saw that it went into Christmas. Okay. Then it went to fantasy. Then it went to HP. Okay. Um, Cupboard. Okay. What if now it will see exactly like where do you stand. Okay. So now transformer cross encoder comes in. It actually goes in more deeply, but it also thinks of like it reads actually all the metadata was there. You had disabled the metadata in two tars. Like you just said that we will do like we did that this it will only read the codes, embedded codes that are there for each hashtag. Okay. And same goes for the previous one that was wide and deep. Okay, wide and deep was totally memorizational generalization based. Okay, and then lambda was totally score based. It was only playing with the numbers at that point. Okay, that Niket is scoring this, so we recommend him that. Okay, we just saw in there that Niket has scored Christmas as 3, so maybe Christmassy movie is more likely on his. These scores match his more, so Grinch is more likely to be recommended to Niket, and then Alice in Wonderland, second point to Niket, is going to be recommended. Okay, so Lambda was working in that function, totally mathematics. Lambda was totally mathematics. Wide and deep was totally memorization and generalization. Okay, like he just memorized that negate like this, then negate like that, and then negate like third movie, negate like Dune 1, negate like Interstellar, negate like Arrival, then negate most probably like will like Dune 3. Okay, and because some another person also liked in the same pattern. Okay, so it just generalized in that way. Okay, is there any chance of mistake? Very highly, both with both of them. Okay, but now the transformer cross encoder comes in. It actually reads the whole hashtags that were there. It is not looking at the scores. It is not looking at the totals that were there. Okay. It is actually reading the hashtags. Consider as that lambda was looking at only the totals. That okay, the total formed for this movie indicate total score was Niket's score was this. Okay, and the Christmas matching score for each of the following this one movie matches that, this movie matches that, so lambda worked in that way. Wide and deep came in. It also added the collaborative filtering that other people would also watch this or like that. Okay, and then two tar came in. He turned all of that into hashtags into smaller codes. Okay, so like but now also with like for example, this movie is Dark Knight. Okay, how would you write Dark Knight now in an embedded code? The Dark Knight is there. How would you write Dark Knight? Um, Probably first you will say that it was a big category of superhero movie. Okay, so SH. Okay, then it was crime, and then guns. So you say SH C G G. Okay, GU for guns. Okay. So it took you to the whole superhero categories. But within superhero categories, Marvel movies, DC movies, all of that stuff, independent hero movies, you know, and local cultural hero movies, all of that stuff comes in under Dark Knight. Do you want to go through all of those movies? Probably no. Okay, it fetched you all the movies that were there. Okay, at this point, it fetched you all the Harry Potter movies that were in the cupboard for you. Okay, let me clean it a bit. I'm just going to erase this line here. Okay, yeah. So, what happened? CX, fantasy, Christmas, fantasy, HP. Okay, but now he saw that within HP there is one another movie that is called what is called Fantastic Beasts. Fantastic Beast, and it got surprised. Oh, hey, what is Fantastic Beast doing in that category? It came into the HP cupboard. What was Fantastic Beast doing in that movie? Probably other HP movies should have been there, but Fantastic Beast came as a totally Easter egg for him. So, what it is doing? So, what to do now? So, now at this point, the transformer cross encoder would come in and read the actual hashtags. Okay, now he knew that Niket likes Christmas movies a lot. He's a 3 scoring for it. Does Niket Fantastic Beasts is a Christmas movie? No. So drop it. Pick the other Harry Potter movies and show it to Niket. So Transformer Cross Encoder is the one person who actually reads all the hashtags of metadata, and it's actually very busy. It's like the brainy wired nerd that you have. It will read. So people, the good techies, they actually smartly used all 4 of them together. Okay, that's what it was saying me right here, showing me this matrix. Where did it go? Yeah, with this diagram. Like first of all, um, there is candidate retrieval. Okay, um, there are thousands of millions of people and then thousands of items. You know. Okay, and then so based on my understanding, two tower would connect me with the appropriate items within the seats, some of the categories. It will connect me with some of the categories. Okay. Now LambdaMART and White Deep would come in. First of all, White Deep would come in. It would connect me further ahead with some of the more categories. Okay. For example, this Tutar had the gist of like Niket likes cozy movies. Niket doesn't like blood gore movies. Okay, so it sent me to that one, like it considered a big shopping mart. Okay, and it saw that like you went to buy some good trousers for yourself, or buy dresses for yourself. It saw that Niket likes maybe beach kind of place, or maybe Niket likes very formal dresses. So he sent me to the formal section. Tutar sent me to the formal section. Okay, now Wide and Deep was there and Lambda was there, the other salesman. What did Wide and Deep thought? That somebody who comes into the formal section, first of all, he likes to watch the most expensive suits. Okay, or maybe the medium costed suits. Okay, so he took me to the most expensive suits of all. Okay, and then he the medium suits. Then he noticed, what do I like? Like am I um like cost very like cost efficient? Like am I looking like person who would buy a good suit or not? Okay, or LambdaMART would just judge me from the sideways. If he is a person, like what kind of clothes am I wearing? Am I a college student who is wearing like college students, a cheap shirt, maybe canvas shoes and everything, or maybe I'm wearing like very like leathery stuff, leather, pure leather shoes, and very heavy formal three-piece suit. So Lambda would judge me, and same the YT would judge me. Then Lambda would take me to that one section where rich people actually buy, or Lambda would take me where medium salary people buys their stuff. Okay, it takes me to there. Okay, and now White Deep comes in. White Deep is like, oh hey, you know what? Uh, this is what other people liked. Maybe Brad Pitt came in last week and he bought this for his himself. Okay, he will start suggesting me all of this. And also he will notice that what do I like what kind of suits I'm looking at, right now. Okay, and then LambdaMART has done its job. Like he judged me heavily or based on my looks. Okay, and consequently, if I'm into the cheaper section, he will show me the suits, like what kind of suits. Like it's I want a one-time suit, maybe rental suit, maybe like poor washable quality suit, some what kind of suit, or maybe dry cleaned suit, something like that, you know. So it will show me those kind of suits. And then cross encoder actually comes in, and then cross encoder asks me, sir, what is your budget to buy this suit? Like, what's the highest amount? What's the least amount? Then I tell him that, hey, I am looking for this, I'm looking for that, and that. And then cross encoder would be like, okay, let me bring you 5 to 8 pieces, 5, 6 pieces that I think would fit your category. Then he goes into his cheap section and gives me like rental suits option or everything. If I was in the heavy section, then he goes into and gives me a suit section of like expensive leathery suits and everything. Maybe I was looking for uh, suits that were worn by some actors in movies. So it suggests me those. That's when transformer cross encoder comes in. So it is tension based and list-wise. Highest accuracy, but at high compute cost. Now sixth is re-ranking and diversity injection. Okay. What is ranking and diversity? So no two back-to-back items from the same creator. These are kind of constraints that you can always add into your transformer cross encoder. Okay, and then minimum X% of new releases in top 10. You know. Now this is you have done the first time ranking, and now you are looping back again. Like how should transformer cross encoder function? Okay, you are adding rules to it now. Your custom rules. These are custom rules now. Okay, mandatory freshness float, sponsored slot, if any. Okay. Then diversity, D, exploitation. Okay. So that is that. Okay, just wanted to add one more thing in here. I'm using maximal marginal relevance. Algo. Okay, MRR Algo. So what is maximal marginal relevance? Is algorithm used in search and text retrieval to balance relevance to a query with the diversity among the selected results. Okay, just that same thing that we discussed earlier. Transformer cross encoder. It will read all the hashtags very thoroughly. So MRR maximal marginal relevance is going to use that. Okay, this was also used in earlier versions of ChatGPT. Uh, there is a formula as well here. If you want, I can write it. MRR score equals to how do I do it? Lambda. There we go. Okay, cool. It's just a formula. I do not want to write it. That's it. Now, probably I am going to write the most interesting thing that you are going to find. Okay. And it is what to consider while designing. Okay. ठीक है. So first of all is dimensions, and then trade-off. Okay, and then recommended default. I mean default settings that we would that is to be recommended. Okay. So first of all, that dimension is accuracy versus serendipity. Okay, what is serendipity in? Okay, serendipity is like a stumbling upon by the random functions, random order. Okay, stumbling upon these things. Okay, high accuracy equals filter bubble. Cool. And high serendipity is totally irrelevant. I mean, you cannot vouch for it, like what would happen or what would it show. The same case, it can show 18 plus adult content to a kid. Probably, yeah. Okay, so 85 over 15. Maybe you can use this accuracy to serendipity split. You can use that, like 85% is totally accurate based on the filters that about the users, and maybe 15% can be totally random stuff. If there is a like a child filter totally, then yes, definitely you cannot show this decreases, this changes. Okay, that's a like custom condition now. Precision versus recall. Okay, few perfect picks few perfect picks versus many okay picks. Okay. Um, this is totally platform dependent. And lean For video, we call for music. Okay. Few perfect picks versus many okay picks is there. Implicit versus explicit goals. Okay. Labels, sparse labels versus noisy proxy. Okay. Implicit as primary and explicit as calibration. Okay. Precision versus recall is like totally like how we saw in the wide and deep, how precise it is and how deep it can penetrate with the wide and deep. Okay, but also uh, with precision is like how perfect those matches your profile against the item's profile, how precisely it matches. And okay, recall within recall is you know it is 50 to 60% accurate. Okay, totally depends upon platform. Some platforms actually do it very precisely. Netflix does very precisely. Prime does it kind of not so precisely. Actually, Hotstar does not do it precisely. Hotstar searches was very bad. You know that, remember the time when Geo hadn't bought Hotstar, and then at that time, and yeah, recall for music also it works. Like if you search for one song, for example, you search for Taylor Swift song, probably it will also just suggest you some another songs like Selena Gomez. She is in the same genre. Ariana Grande, all of them are same genre. So probably it is going to show you some songs of them as well. Implicit versus explicit signals. Not goals, it is signals. We saw implicit versus explicit right here. Okay. You know, implicit is play, purchase, law, and then explicit is star ratings, etc. Um, okay. Implicit should be always a primary. Okay. And then explicit as your calibration that, okay, maybe it was a good movie or bad movie based on user reviews. Okay. Global, personalized. Guys, just a small note. I feel typing takes a lot of time. So next time I'm going to use the pre-typed screenshots. Okay. Trending now versus niche taste. Okay. These are all different dimensions, guys. It is totally up to you. How do you want to design? Okay, you can probably just use this one to just show on your homepage and everything, or maybe you can use all of them. YouTube uses just two, three of these. Okay, surface trending, contextually, base feed, personalized. Okay. Pattern freshness versus quality. Okay. New content versus proven content. Guys, this table can be bought up from anywhere. Okay, like you can also ask ChatGPT what dimensions to, and what are the recommended defaults. It will show it by yourself. Exponential accuracy versus data richness. Okay. More data equals better model. Okay. Federated learning plus differential privacy. Latency versus accuracy. Deep model equals to slow. Fast. Okay. So we were at a global versus personalized popularity. It is easy. What is trending right now and what is based on your accurate taste. For example, I like jazz music. Um, is it going to show me jazz music or how much does it want to show me the top 10 music in the charts? Totally depends how much weightage do you want to put. Recommended is like on the surface level trending basically, but based on what I like top jazz music in UK or top jazz music in the world right now, okay, something like that. And then probably when you go into specific niche pages, you can see exactly something of your liking. For example, if I visit a jazz page, I would want to see Bob Marley. I would want to see all of those reggae music and everything. So something like that. Okay, or like trumpet music, or maybe guitar versus trumpet. All of those quartets are there. And then item freshness versus quality. Now, new content versus proven content, like content with the maximum likes or content that has been available recently uploaded, something like that, or a trending movie versus a new uploaded movie. Okay. For example, would you want to see Odyssey or would you want to see what's a Inception? Highly rated movie. Okay. So this is that. And then latency versus accuracy is there. What else is there? And probably you can use freshness decay function as well, so that the fresh videos are decayed over time and they are changed time to time, so that like your most trending movie is always there, but the new movies get changed, revolves. Okay. Private versus data richness, more data, better model, all of that stuff. Okay. And then latency versus accuracy is like if there is too much accuracy, then your model might get slow. Um, okay, so that is there. So you can just add to stage. Okay, fast ANN retrieval plus slower ranker. Okay, exploration versus exploitation. Okay, show safe bets versus learn new tastes. Again, this is totally new. Like, do you want to show him some randomly orchestrated content? Like, hey, do you want to see? We think you will like this niche of content. It is again coming from the collaborative. Okay. Or do you want to see exactly the same data that was shown, based on the data that has been asked from the user? Okay. Thompson sampling 10 to 20%. Explore rate is there. Okay. And then add some below more. Okay. Short term versus long term engagement. Short term versus long term engagement. Okay. Click now versus churn and days. Okay. No, all less thumbnails, all of those thumbnails that are provided with the movie. Like it's a trending movie, it's a new release, it's a um, something like that. And the top 10 movie with the like top 10 in a week movie, like those kind of thumbnails. Optimize for session completion. Plus 7 day 200 diversity versus coherence. Okay, various field versus cohesive mode. Category diversity cap max 2 of same genre in top 10. Okay, so this is all of that. Just a sec, guys. I'm checking my email right now. Scalability versus complexity. Okay. Complex model equals to more compute. Simple features in retrieval. Complex in longer. Okay. Just that's that. Yo, moving further. Now, probably, you know, it is something that you really gonna like. What is we are going to do? Uh, Let me just complete this table and then move further ahead. Like what we are going to do next. Okay. So first of all, exploration versus exploitation. Show safe bets versus not bets versus earn new tastes again. Okay. And then like it is short term versus long term engagement. Again, I told you like it is the thumbnails are based on like what do you want to look for. Okay. And and then diversity versus coherence. If you want to see different types of feeds, for example, movies suggestions like best of blockbuster movies, best of Oscar movies, best of Christopher Nolan, best of action thriller. uh, since you liked Harry Potter, you will also like all of these. Or just coherence, like how prime like earlier Hotstar that did very earlier in stages. Like it would just give you movies like the action movies are like this, Harry Potter movies and something like that. I love that stuff. You know, nothing with etc. Like all those gets the categories change all the time. The feeds change all the time. Okay, scalability versus complexity. Again, if it is a like complex model, higher the accuracy, but more compute required. That's that. Okay. So now this is going to be a very cool thing for you guys. Okay. Those who have missed any other chapters should not miss this chapter. How to add weights. Like when I mentioned exactly like all those different hashtags and all those hashtags in a movie or something, like if you try to categorize, one categorization was like all those hashtags have been mentioned under a movie. Okay, one category is specifically to that movie of hashtags, Christmas, cozy, family, or Harry Potter. But also, if we want to do further segregation of these hashtags, okay, for example, a Christmas movie. Within a Christmas movie, you can also add an action movie, Die Hard. You can also add a fantasy movie, Harry Potter. You can also add kids movie like Home Alone or anything else. Okay, and also It's a Beautiful Life, a dramatic movie. It's a Beautiful Life. You can add all of them. Okay, but Die Hard belongs to its own family, action family. Die Hard also belongs to police family, American police. Same goes with Lord of the Rings or like Life is Beautiful belongs to drama family. Life belongs to Second Life, like Second Chance on Life family. Okay, there's a genre called Second Chance on Life. It is about like a guy has throwing away his life and then he gets a chance to for a redemption and something, redemption arc kind of a movie. So those kind of genres. So genre-based segregation of each content, and then within those genres also separate segregation. For example, within action, it would be co-op action, superhero action, um, teen action, and then girl drama, boy drama action, something like that, couples action, something like that, and then blood gore action, something like that, or adventure action, comedy action, slapstick action, all of that stuff within action. Okay, again within those subcategories would be the superheroes and all of that stuff, superheroes, action, all of that stuff. So how do you do that? For example, Bad Boys. Bad Boys is comedy, yes. Action, yes. Buddy cop, yes. Different subcategories. So all of that, and then badass villain, maybe something there also. So different categories you have got there now. But now, how do you decide what movie is going to be considered under what category? A movie can be considered into multiple categories. Okay. For example, there is a movie Tenet. Science fiction, yes. Time travel, yes. Christopher Nolan, yes. Robert Pattinson, yes. UK movie, yes. Oscar, yes. Oscar winning, yes. Great soundtrack, yes. All of this. But what do you prioritize? How do you want it to be prioritized? Christopher based on Christopher Nolan movie, yes. For example, somebody is searching for a time travel movie. Imagine Tenet is being shown at very last of the places because all of the time travel movies like Back to Future, Part 1 to 3, and then Predestination, Looper, all of those are shown before. And then somewhere at the end is Tenet, a movie by Christopher Nolan. Can you do justice to that? No. Um, so maybe before even reaching Tenet, people would drop off that, hey, I don't think there is Tenet on this platform. Let's check another platform. So what do you do then? You have to decide the weights, okay, and take responsibility of those weights. like how a movie is to be categorized. So now there has to be a method, okay, description, pros and cons, okay. Manual tuning, okay. Then there is A/B testing tuning. Then there is grid or random sequence. Then there is Bayesian optimization. Okay, what else is there? End-to-end gradient descent. Okay, and probably multi-armed variant. Okay. These two. This one, domain experts set the weights. Okay, manual on human labor. Humans are costed very much, but interpretably fast. Con is like if it is doing by humans, then probably it is subjective. Like one expert or critic, so-called critic, would rank or think of a movie in one way. Probably it can backfire on them as well. There is always chance of human error. So subjective it is. Okay. So you cannot do it on a bigger scale because also human is required, human intervention all the time. Then there is A/B testing, run variants in production. Like again, human intervention is required, but there is real business logic to it. Like how people are looking at the trend. You can like add it in a mix of hybrid filtering, collaborative as well as the textual filtering. You can add a mix of both. Like maybe if you want to want people to reach Tenet movie again. Okay, one way is you watched three of Christopher Nolan movies. Maybe you will also watch fourth Christopher Nolan movie, Tenet. Okay. Then second is um, you saw Predestination, you saw Dune, you saw Interstellar. It's all sci-fi movies, and then again contextual. Okay, but now majority of people saw um, all the time traveling movies. If there is one logic to it, like all of these people also saw time travel. Who all saw time travel movies also saw Tenet. By the way, guys, do you know what's the one Christmas movie that's also about time traveling? And it is very subjective, though. It was considered like this is a small side question, though. Do you know such Christmas movie that was also time traveling based? Exactly. If you have thought of Harry Potter and the third part, what was called? What was the third part of Harry Potter movie called? What that came after Chamber of Secrets and before Goblet of Fire? Uh, Prisoner of Azkaban. It's a time travel movie, so it can be suggested as well there. Okay, but watching all the patterns and then setting one, is probably slow task and requires traffic. The stakeholders would be growing impatient by then. Grid or random search. Okay. Sweep. Parameter space offline. Systematic. Yeah. But expensive compute. Okay. What is Bayesian optimization now? Okay. Let's just copy and find it out. It's something like a sandbox mode. Like it will take a bunch of users and notice their patterns, and then you can apply this pattern on global users. Bayesian optimization runs on heavily on transformer cross encoder. Like it will go very deep and read all of that stuff. Okay, and it would require a lot data segregation, but it will read all of that stuff and then suggest you accordingly. But thing is, you only add a limited users, so that it doesn't get distorted, and then you try to apply it. Okay. Surrogate model guides search. Okay, so it's a sample efficient and also complex to implement. Okay, because it's operating in a sandbox mode. End-to-end gradient descent, I just told you. um, Neural net learns optimal blend. Okay, and then optimal theory. Again, black box mode and hard to debug. Okay. Multi-armed bandit continuously update weights via feedback. Okay, adopts in production and then exploration costs. Got it? Oh, so this is that multi-armed bandit is like all of them combined together. Just a pro tip for this. Okay, just a pro tip. Start with the manual tuning. Okay, manual tuning based on intuition and everything. Start with the manual tuning, and then slowly validate your intuition based sequences with an A/B testing. Okay, and then switch to Bayesian optimization. Okay, like just create all of those different sequences, A/B test them, and then send it to the sampler Bayesian optimization. It will create the perfect feed for you, feed or maybe different categories of stuff for you. Okay, Bayesian optimization, and then also maybe end-to-end gradient, but never jump to directly to the end-to-end gradient. Probably it is hard to debug, like very hard to debug. It's a nightmare. Okay. So next problem is, for example, you have created this weight determination model, but now you want to do is uh, but now you want to do is keeping it customizable in production. Okay, so like how do you configure and then reconfigure all of the stuff? Okay, so for example, sample code is like, shall I show you sample code? How do I show you? Shall I just write it? How do I do it? Um, Guys, I am going to quickly change my method of, you know, I'm going to take a pause and quickly take out my notes somewhere else. I'm going to take a pause now. Okay. Cool. Back at it again. So we're going to look at like how to add customizable weights. Okay. So for example, this is like block of a code that is there. Like it's a JSON file. Um, this is just a no deploy need. Okay. So weights, like you mentioned weights like this, like collaborative. Out of one, this is all out of one. Okay. Weights collaborative should be 0.35. For example, this is using different models. Like they have probably 5 models working. One is collaborative, one is content based, another is contextual, and then trending, and then diversity. Okay, so collaborative basically they have added the weight of 0.35, and then content based they have added weight of 0.25. Okay, and then contextual, again contextual is like location, device, and everything. They have added 0.20, and the trending should be 0.10. Like based on the final list should be always in the trending fashion. Like highest rating should be, or most watched should be the at number one place, and the diversity should be 0.10. Maybe amongst all the Harry Potter movies, you can probably throw in Fantastic Beasts. Maybe you can avoid throwing in a Fantastic Beasts. You can add Alice in Wonderland. Okay, and then in the diversity rules, max same genre in top 10 two times can add. Like whatever genre he's treating at that time, only 2 items of that genre it can add. Okay, and then minimum new release, it should be 0.15 in that capacity. Okay, freshness, decay is exponential, and half life days is 14. Okay, exploration rate is 0.12. Surface overrides, home home hero trending weight is 0.40. Okay, because you watched is 0.070. New release row freshness 1, and collaborative 0. Okay, now let's come on to like all this is just a second. This is all based upon this was just a block of code that was written. Probably developer could write it and pass it over the PM to just show it to them. Okay. And now we have key production patterns. Um, Key production pattern is like what is um, the major pattern that you're going to show across all of the product. Okay. For example, feature flag. Um, There is feature flag, there is a pattern, and then what it enables, and then what is the example. I will give you an example as well. Okay. So first of all, feature flags. Based on that feature, for example, um, what is a feature of that particular item? Uh, you turn the signal on and off per experiment, okay, and then enable social graph for 10% of the users. Okay. Then what is the surface level config? Different weights per placement. Okay. Homepage hero is not email recommendation or not search. Okay. Guys, it is working for you. If I'm just reading pre-written data, shall I write it on the stuff? I feel I should write it on the stuff. Like it also gives me times to think. Just giving a plain, blatant presentation does not work for me. I shall try to write it again. You know what I think is. Nonetheless, we continue. Okay. So user segments override how much user segment override is coming from collaborative filtering. Okay. And then different model per cohort. For like it is A/B testing now, different cohorts. Okay. For like users A, B, C, D, you want to see like how they all collaborate within themselves. Okay, for example, take some 1,000 users and see how they collaborate. What's the probability of their collaboration? Okay, and how much is the success rate? And same different cohort, different patterns make different patterns for them. Okay, and how they collaborate, all of that stuff. Yeah, the best pros and cons are power users get collaborative heavy, but new user also like gets to learn from them only. Okay, new users. Business rule engine, inject non-ML logic, totally out of the blue logics. For example, no horror in kids profile or no adult in kids profile, or sponsored slots. You would want to like business rule engine, shadow mode, test new feature without showing to the users. This is all key production patterns that are mostly used. Okay, log new model output, like it's like probably beta testing. Like you created a new model's output, like this new model recommends people based on that, but you show it to your beta users, not deploy right now on the main production. Maybe show it to the beta channel first. Okay, and then there is canary deploy. Um, Again, works like alpha beta models, not production exactly, but you deploy it for like once the beta has passed your ML model, you would want to show it to 1% of the users. Maybe it can be selective or maybe it can be random. Then increase 1% to 5, then 25, then over 100%. Like it can be within week or it can be within a month. You see, like selectively that's the success rate, and as well as you also see at functions like sandbox mode, like when you launch it for 1% people, it forms a patterns for those 1% people. Okay, and then probably you add another 5%. It's easier for model as well to digest the new data and then function on it, and then maybe give out a good output. If you will not overwhelm it massive data set, okay, you will think that it is working very slowly. So canary model works in that capacity. So there are two advantages of using the canary deploy. For example, one is like you can also see this output with the selective user groups, as well as your model also gets time to function quickly. Otherwise, if you will overwhelm him with the data, he will just sit and start functioning with the data. Probably you will have to wait like until and unless it churns out the whole data. Okay, and then fallback chain is always um, it's a graceful degradation, like a manual input, like we saw in the previous document. Here, where it is, not this recommendation. Yeah, manual tuning. This is you going back to the manual tuning, personalized and then editorial picks and everything. This is that. Okay. So probably a hybrid model architecture usually looks like the model got user's data, then it divides it to CF model and then contextual model as well as a collaborative model and context based. Okay. User items, it has all the metrics, and then item, all the embeddings, context has time, device location, okay, and then weighted blending, like they can all work together at the same time, and then you can put the weighted blending based on like what to prioritize, if you want to prioritize CF or a context based or contextual model, it, you prioritize and then re-rank, and then probably you can also add business rules or diversity or freshness on top of it. These are all custom rules: business, diversity, freshness, and then you get the churn out of it. This is the overall functioning of a recommendation algorithm. This is how the recommendation algorithm works. Okay. If you want, I can show you the architectural diagram as well as comparison tables for different products. Okay, I will quickly go through it. I had taken the screenshot of it. I will go through it quickly for different tools. We are comparing Netflix, Spotify, Steam, Amazon. Okay, Netflix has primary signal of watch completion. Stream has Spotify has the stream rate and skip rate, and Steam the game aggregator, purchase and playtime. Amazon has purchase and repurchase. Okay, and main algorithm family for Netflix is tutor and contextual, and for Spotify is context based audio features, and then second also collaborative. People who heard this song also heard this song. Okay, and then for Steam, collaborating, people who saw this game also saw this game as well. Who saw GTA also saw GTA San Andreas, GTA Vice City, and then he also saw Sleeping Dogs. Okay, and then Steam actually has a lot of metadata with their games. Okay, and then Amazon has item to item collaborative, and then deep learning based on that, based on the metadata. Their cold start approach is if a new user comes in, how do you want to show the data to them? Okay, Netflix probably has onboarding and geography based. Like they will ask you right in the beginning, what kind of genres do you like, personalize a bit and everything. Okay, Spotify has a genre server again, and then their most of the songs are on autoplay basis. Like you play one song, it will start suggesting you another song, and then it will record if you want to listen to that or skip that song. Okay, so basically their autoplay feature is just checking you out, how do you respond to song. Same goes with Steam. First of all, it will check out like what genre you mostly visit, and it will bombard you with those genre of, and then probably if you start adding friends, then it will note like what games are your friends playing. It will start suggesting you accordingly those games. Okay, and for Amazon, your watch history and your purchase history, that functions accordingly. Like if you saw again suits, like three-piece suit or two-piece suit, it will start recommending you suits, and then maybe some another clothes, but mostly would be men wear on your feed. Okay, until and unless you venture into something else, then the model would get updated. Otherwise, it is going to bombard you. This is very bad thing with Amazon, but it works for them somehow. Okay, and then diversity mechanism. Um, they have their like row level of genre caps, Nolan's top 10, Oscar top 10, and then Netflix. Like, this is we're talking Netflix, and then probably best in US, best in Europe, best in India, best in Asia, and best in action, best in superhero. All of that. Spotify has mood or energy diversification. This is something like very fascinating. Now Spotify has added metadata or hashtags to their songs as um, probably as like high energy or low energy songs. Okay, it's a party song or it's just like a sad song or it's a low energy song, all of that stuff. So it also remembers at what time you were listening to what kind of song and what time you were listening to what kind of song. So Spotify also remembers that. Okay, and Steam has like a totally tag based spread. They do not do much into ML or DL, but they have tag based. Okay, like for example, open world games. If you will start exploring open world games or driving games, it will start suggesting you GTA series, Need for Speed series, Forza series, all of that stuff. With Amazon, probably they have their category rotation diversity. Like they will keep suggesting you different categories of same item. For example, you saw suits. It will show you suits based on woolen. It will show suits based on summer wear. It will show you suits based on formal wear or office wear, all of that stuff. Okay, it will show you suits like that. And then maybe also maybe a random category will also be in there, but within the same subcategory. For example, if you saw suits, maybe for men, other subcategory was men. So it will pick the men section also, shirts and trousers set. It will also show you. It can also show you shoes. Okay. Now with exploration, you have 15% chance they have set. With Spotify 20%, Steam 10%, and Amazon 8%. Okay. Again, this is what is working right now. Okay, based on the data I collected. They can vary. It is totally in their hands. They can vary at any moment. Catalog size, they have 15,000 titles. Spotify, they have 100 million. And Steam has 70,000 plus games. Amazon has 350 million products. Got it? So this is comparison table platform approach comparison. Okay. By the way, I was just playing Wordle, guys. So let me show you something cool, funny. So I asked Wordle, help me play Wordle, 5 alphabet word, center is N, like third digit is N. It suggested me crane, plant, shine, stand, bring, money, alone, point. Why the N is at the end of it all? Why? No idea. Shouldn't it be N at center? And then it's asking me green, N is in the center, two blanks, N, and then two blanks again. What the hell, man? And then I asked it, like, what is this ChatGPT? Didn't I tell you the center word is 5 letter word is N? Then why so many cross questions? What will all these words with N at second last? Is this how you are going to conquer the world? Okay. And then it gave me the right interpretation as well. Still, it's suggesting me crane, plane, slant, grant, giant, chant, shank, thang, trang, tring, bland, blend. What is this? I mean, what is this? Come on. And then I pointed out again, all the words are N at F, fourth place, you're right, that's on me. And he started laughing. Center. So, crane, where N is fifth. I was simply wrong. Okay. And then he finally corrects himself. Tenor, honor. He rejects Venom. Venom he rejects. Venom N was the third. He rejects Venom. Minor he rejects. Okay. And then Manor, Annoy, all of those he rejects. What the hell, man? What the hell? I don't know what ChatGPT is thinking. So I just tweeted for Sam Altman something. Are you sure this thing is safe for kids soccer match podcast? I just taunted him. I wanted to taunt him. Wanted him to feel it. Okay. And then keeping it customized table production aim is back to the thing. We have done architectural diagram and the comparison. Okay. Do you want to see probably the CTR for like response rate that is currently running for each algorithm? Okay, let me tell you actually. For I'm going to use the pen here. Not this pencil, yeah, this one. Okay. If there is no recommendation. Okay, it usually operates on 2.1%. Okay, it usually operates on 2.1%, and then if there is only collaborative filtering, it usually operates on 4.8%. This is right now the current data. Probably boring for you, and ChatGPT or Google can also tell. Only content based, okay, 3.9%. Okay, and then maybe the fourth is hybrid. Okay, hybrid is 7.2%. Okay, and then hybrid plus deep learning, it runs at 9.1%. CTR. This is CTR, click through rate. So this is how it works. Any Google can tell you this stuff. Okay, let's come on to, since we are a product manager, we are obviously not gonna leave without doing PM metrics. Okay, metrics to track, heading. Okay, so first is instrumentation metrics. Okay, so we have within instrumentation metrics is let's insert yeah, I'll just do it like this. Okay, first is CTR. Okay, that's our clicks or impressions should be greater than 8%. This is the industry standard for these. Okay, watch or play, watch or play rate. Okay, plays. This is recommendation shown. Okay, should be greater than 40%. Okay, watch rate, like what the movie should be watched at least 40%, and the tool is amplitude or mix panel to show them. Okay. And then there is session length. Okay. Average minutes. Okay. should be greater than baseline, whatever baseline do you decide. This is customizable. Okay, and then in the shopping is catalog coverage. This is unique item shown, or the total out of the total. Okay, unique item shown out of the total. Okay, and it should be greater than 60% industry standard. Like how much items are you going to show at that one time out of the total? If there are 350 million products, how many items can you show on a unique basis, like not anything um, repeating? Serendipity score. Okay, non-obvious hits out of total clicks should be greater than 15%. Okay, then churn signal, okay, should be less than 5%. Okay, this is 7-day inactivity we are talking. Most important of all, revenue lift. If all of your function is working something somewhere, should be greater than 10%. Okay, 10% revenue should be lifted. Okay, and then what else is there? You can always add a experimental design checklist. Define your primary metric and guardrail metrics before running the A/B test. Okay, run for a full week. Okay, run that experiment for a whole week. Captured, that should include weekend versus weekdays difference. Okay, ensure the statistical significance is less than 0.05. Okay, um, okay, then let's come on to more success metrics. Okay, user engage under user engagement, it would come CTR, completion rate, session length, all of this stuff. Okay, and then there is business outcome. Okay. Revenue uplift, then there is subscription renewal. Okay. Catalog coverage. Okay, and then demographic parity. System health, error rate, cache hit rate, latency, all of those stuff. Latency, error rate, cache hit rate. Okay, and then long-term retention. What is it? Like 7-day retention, 7-day retention, 28-day active rate. Okay, churn prediction accuracy. Guys, this is all math based. You do not need to go into it. Okay, and then last is Vanity Metrics. raw CTR, and then session length, and then rating average, top and popularity. All of these are now raw CTR is probably kind of misleading because thumbnails can always make the product look good. Even think of in Amazon, people can always come to the product, but would that make it purchase them? Maybe not. You know, should be if the CTR and the loop cycle rate is completed or not. The overall, you watch a movie and then return to catalog, or you buy a product and then maybe return for a second purchase. Session length, like passive autoplay inflates it. Better alternative is active engagement rate. Rating average, selection bias. Unhappy user stops rating. Okay, when people do not find something good or the find series bad, they do not rate usually. Okay, rating count into weighted mean should be the alternative to it. Rating count into weighted mean, how many times they had actually rated, okay, and what was their average rate means. For example, somebody is rating rated just 3-4 times and always negative rating. Okay, rating count 3 into weighted mean is also something around 0 or 1. What would that mean? Just 3 score is okay. And then um, people watching top 10 popularity, it is no good metric. You are just serving the obvious hits. Okay, catalog coverage and long tail share. And then there is, you're always running a problem of over personalization. Okay, so what happens is within over personalization, why did it like that? Coming on to it, signs of over personalization is sometimes catalog coverage drops below 30%. Okay, only 30% of the items ever get recommended. We saw that it should always be more than 40%. So below 30%, only 30% of those items get repeated and repeated again. Users cannot even find something. Disney plus Hotstar is having the same problem. Okay, users in the same demographic cohort see near identical feeds. Okay, like if I am in India, most likely people in India would see almost same kind of feeds for them. Okay, that is a signal that it is not working. Only demography is working at this moment. It is not a hybrid cycle. Okay, or it's not working as in like my title choices. Then long tail creators see zero impressions, only blockbusters surface. That is one over personalization. Okay, somebody watches blockbuster. For example, I shown you only blockbuster movies here. But what are the indie movies on everything that are there? For example, Robert Pattinson's Good Time. Would it be recommended here? No. But it is robbery, family, crime. Okay, that kind of and guns. So it should be recommended. Okay. And then user surveys shows that they feel stuck or bored, an explicit overload signal. Okay, and then churn cohort analysis show you churned users have lower diversity scores 30 days prior. Okay, and then you can always say that you can split discovery and personalization by user engagement rate. Okay, user segment. Okay. User segment, optimization percentage, and then discovery percentage. Okay. 0 to 70 user. Okay. Personalization should be 20% and discovery should be 80%. Okay. Then weekly visitor, once in a week visits. 50-50 should work for him. Okay. And then regular daily user. Okay. 70 and 30. This is how should be. This is an idea. Okay. And then power user. Personalization maybe 85 and then 15. And then a user who had once churned away, he stopped paying for your Netflix service or anything. Probably you would want to show him user 40% of personalization and more discovery for him. Tastes may have drifted or they should relearn. Okay. For power person, I had done 15% discovery because they have deep taste data, minimal disruption to them. Okay. For regular, it's a strong signal, so learn personalized. For a weekly user, taste forming balanced feed should be there. And then probably surface specific strategy. Okay. Another table for 2 surface and then P/split. Okay. At home feed, you would want to see 60/40. Okay, because user expect familiar but want to be surprised as well. Okay, because the watched row should have 95/5. 5% discovery, 95% personalization. Obviously, it's from the name. New release row. Okay. 20/80 maybe, because new release is all about discovery. Now, we should not give a personalization something there. Search results. (70/30). Okay. And then email engagement. 50/50, because you're writing an email. Email doesn't matter. You never know what is going to hit them at that point. Autoplay next episode. Okay. 99% of the time, because they are already in the one series. 1% time discovery. We should allow them discovery. Like after end of the series, maybe you should tell them, maybe do you want to watch, like if there are there's a 10 movies you're going to suggest, maybe one should be totally out of the category to surprise them. Uh, then we have but now the thing is how AI has entered the picture. This is now AI paradigm shift. Sorry for the bad spelling. Now we have AI paradigm shift. Okay, how AI has entered the picture and how AI has changed everything. So what is happening is like classic recommendation system is kind of declining now. Now this AI era system can generate, synthesize, and even explain the recommendations by itself. Probably higher on compute, but the outputs can, outputs are kind of grayish, like if it is working or not. Okay, it can create personalized content on the fly. For example, Spotify DJ is a new feature. You can actually read the lyrics as well and suggest you lyrics, songs with same kind of lyrics, same kind of tunes as well. Okay, that is one thing. Netflix has auto trailers. You never know what part it is going to cut within the movie and show it to you on the fly. Okay, and then Amazon product descriptions per user. It can actually read what you saw last time and then what you wish listed. And if you're seeing totally different product, it will auto curate for you the description that you know maybe you will like to buy it since you also bought. For example, you're looking for dog food. Okay, last time you bought a dog collar and the dogs. Based on the dog collar size, like you bought for a big dog, like a Labrador or Retriever size, it is going to suggest you like you should buy a big bag, large bag, rather than a small bag because it will empty up in a month or week. You would do not want to do that. You would want a bag that runs for 2 months or 3 months time. So it will change the description. Okay. Next time we will cover AI. Okay. um, like AI metrics to add to your dashboard, as well as new challenges posed by AI in detail, like latency versus intelligence trade-off. Is there hallucination and recommendation explanation, catalog size versus LLM context window, bias amplification, model collapse in feedback loops, explainability, and regulatory pressure. Okay. Next, we are going to okay discuss this. Not to close the loop on the over personalization of the feed, I can suggest you some mitigation strategies. These mitigation strategies are like exploration budget, like add some exploration budget in the feed. For example, give some space to also explore, like reserve certain X percentage of the slots. For example, if you're suggesting movies, some slots should also be that are totally new, that are coming from the new category, not the personalized category. For example, trending or new releases or something like that. Or Netflix does, or Steam does, or Spotify has this whole section of new releases. Okay, and then there should be a maximum marginal relevance. Okay, um, there should be like you should not just add items for the sake of personalization there. Okay, these items can also be added because should not be only added because like they were personalized and you start suggesting them bad suggestions. For example, some of the items like some of the redundant items should be penalized in the ranked list. Okay, um, for example, there should be a difference between relevance and diversity. There should be a balance between it. Okay, like half of it should be relevant and half of it should be diversified as well. The ranked list. Okay, and then temporal decay on interest profile. Um, like after 90 plus days, your interest should start decaying. Means your interest should start to pick up on collaborating filtering choices. Okay. Um, for example, if you are watching some movie like action movies, or maybe you are not a returning user, probably your feed when you come up after 30 days or 90 days, you should feel like your feed is changed. It is not staying there. Otherwise, movies may not be added or might be added, and it will keep suggesting you the same and same movies again. Like if you're loving Harry Potter, it is going to keep suggesting you Harry Potters and again, all the Fantastic Beasts and again. Probably it should stay there for 90 days or maybe lesser, maybe between 60 to 90 actually, between 2 to 3 months, and then it should reset or maybe change accordingly to the collaborative filtering. Okay, and then cross category injection. Force at least one item from the adjacent genre. That's pretty much easier to understand. Okay, like if you're watching too much of action movies, uh, cop action movies, probably add a superhero action movie in between them. Okay, and then serendipity layer. Inject high quality items user hasn't seen. Okay, um, yeah, this is also pretty much it, like top trending or something, or something like that, or Oscar worthy movies, all of that. Just another feed. Even if you're talking in terms of X, probably it be. Okay. And then interest graph pruning. Remove edges in user interest graph if unused after 60 plus days. Again, this is the same thing that I said, temporal decay. Like, like start um, start to blur the boundaries of the user, or the like yeah, boundaries of the user if it is unused for 60 plus days. Just prune the boundaries and start mixing that content, personalized content. Okay, that is one. And then there is a big problem with new approaching user. For example, there are actually two cold cases. Like, let's just first take an example of a new user. So what happens? The user signups. There is onboarding survey. Okay, and then 3 to 5 genres are there. Okay, there are some 3 to 5 genres or taste, and then popularity wise also. If I say he selects on while onboarding, he selects 3 5 genres or taste. Okay, and then popularity weighted baseline, like best in class, per category, all of that stuff happens. Okay. Um, the best in class of that category. For example, he selected fantasy, so best in that category, Harry Potter is or again Lord of the Rings. He sees, okay, and then he starts to play scape. First this is his first session, and then develop into the ecosystem. Okay, and then um, collaborative filtering also kicks in after 20 to 50 interactions. Mean to say on a day 7 or day 14. Okay. Like Now, first of all, he was seeing very personalized choices, but now he is also seeing what others saw. Okay. Then after 200th interaction, that is the end of the month, totally full personalization we add. Okay. But keep a margin in personalization. Okay. This is one. And then there is an existing user path. Um, like a user who has been using for 2 years now. Okay, he comes back, there are hundreds to thousands of events for him that he had interacted, and those were recorded, 100 to 1000 of events. Okay, so that's collaborative filtering is also trained, session transformer is also trained at that time. So it has been deeply embedded with his system, that we saw with code CX, HP, F for fantasy, AC for action, all of that has been embedded. Okay. And so hybrid model operates at 50%, we saw, and then contextual also operates at 20%, then content also operates at 20%. Okay. At maybe just maybe trending at the last 10%. 50 plus 20, 70, 70 plus 20, 90 plus 10 of trending 100. Okay, so hyper personalized feed is generated within 100 of milliseconds, that is 10 seconds. Okay, so but now there is a problem in between this journey, and that is um, like cold start problem. What is like when the new user comes in, he hasn't interacted much. There are no recorded events for him. Probably there should be hundred to thousands of the interactions to actually make that personalization work. So that is one thing, and then model applicability. Since he has interacted very less, you cannot just say that somebody who has watched the first movie of Harry Potter, he is going to watch second movie of Harry Potter. Maybe he liked or maybe he didn't. Maybe he liked the genre or maybe he was there by mistake. Okay, so it is can be partially rendered useless at that time. Same goes for content filtering as well. Okay, content filtering can be bit of the usage, but not specifically. Okay, and then there is quality floor. So what user sees on his screen is like what is the most popular on his area, or what are the genres that he saw, what was the most popular from him for him. Okay, only then we can personalize it for him. And for existing users, you can always personalize it deeply for him, like what are the popular for your genre of movies. Okay, so and then there is primary risk for new user is you can always suggest him bad movies and then he can churn off. Okay, and primary risk for existing user is um, he can, let's just exist in a bubble, a filter bubble. Okay, and you cannot just think of he is seeing something else. He is just seeing like what he has already seen. Probably you have also done like just a fun fact, side fact. You have already done this thing in Instagram when you are watching the reels very quickly, or maybe on YouTube or TikToks. When you're watching the reels very quickly, you get bored at certain point, like after 2 3 hours of watching those reels, because you feel these reel all of them are repetitive. You liked a song, that songs reels are being repetitive, and at certain point you see that people are also copying each other's content. Okay, if somebody made a joke or made a dance step, did a dance step, uh, if this you will hear this song again, you're going to see the same dance steps because people would have just copied each other. Okay, so probably there is no chance on the earth to so that you get bored and then maybe you kill the app and then you go on to the another app and then you return back hoping that this all content would be resetted. And if it's not working, then you go on to the special Instagram or TikTok setting where you reset your whole algorithm and then the fresh feed comes in. Okay, so that is long term staleness. So you gotta break out that bubble once in a while. Okay, and then exploration versus exploitation. New user must explore heavily to learn how it actually works and for us to also record their events. And for the existing user, they can exploit with small exploration rate. Like if you are just noted very purposely that a user who likes very fantasy movies, you're going to show him all the fantasy movies and series. Okay, uh, but he is just exploring things like for example Daniel Radcliffe. Okay, he explored Daniel Radcliffe, the Harry Potter actor. Okay, what else he has done? Now he has never done any other fantasy movie in his life ever. He has done a very adulterated movie called Skirnakimbo. He has done what was that name of the where he is almost a dead body, as good as a dead body. Okay, and then he has done some indie movies all his life. Okay, all different genres. If you go exploring Daniel Radcliffe, you will probably break your own personalization algo. Now the algo thinks that you also like action movies or indie movies. It is going to show you indie movies as well. Maybe it will look good for you that oh, something fresh is coming up, or that 10% were reserved for totally out of the context random suggestions for you. Maybe it will look good or maybe it might not look good. Guns Akimbo is a movie that not a lot of people can watch because somebody is walking naked. A lot of people are walking naked, and then his gun hands have that guns thing stitched to it. Looks very bad. It's like looks ugly. Then there's a movie called Horns. He has a horn thing. He forms a devil something. It's also a very bad movie. uh, you know he tries to cut those horns as well, something like those happen. And he walks naked almost in that movie too. So that is one. And then latency budget is always there with the new user, simple model. Like there is no much personalization, just couple of recorded events. So probably faster personalization, faster responses, but a lot of variability. May or may not like it. Heavier models, lower latency, but justified. It is justified. Okay. So, how do you mitigate a cold start mitigation playbook? Okay, how do you mitigate the cold start problem? Now, cold start problem is the like what we saw, the new user comes in, there is a lot less data. How do you even onboard him? Okay, so you ask him right during the onboarding, like ask a survey like what is his taste and everything. Okay, and then during onboarding, take also signals like what was his sign up source, device, or region, like his geographical location. For example, if I'm from India, I would love to see my Indian continental, subcontinental, regional language movies. Okay, and within India as well, we have multiple languages. Okay, so that is something. So probably maybe city based as well. Okay, maybe somebody sitting in Arizona would not like same movies as somebody who is sitting in SF. There's a huge difference. Or maybe somebody who's sitting in Paris would not like somebody who's just 10 kms away across the border in Germany or maybe in somewhere else. Okay, so something like that. Or even funny thing, somebody on the right side of the Berlin Wall would not like same movies that on the left side of the Berlin Wall. Something you can also say that. Yeah, is it right or left side or west and east side? Yeah, west side of Berlin Wall and east side of Berlin Wall. Yeah, those two people can also differ. And then device, what device he has signed, phone, PC, and everything. and then sign up source, like he was signing up from Chrome or TV or whatever, Chrome, TV, any browser or app, or where it can give you a bit of hint as well what he will like if you think very deeply. Then popularity weighted cold start, show biggest, easiest is show them the popular stuff based on their geographical locations or the question they had answered. These will form your first five list only. Like show them the highest popularity in the whole world, one for list one, and then second is highest popular in their regional area. Third one is highest popular in their favorite genre, and then uh, maybe fourth or fifth you can also show them like people who liked this kind of movies, like these are your genre of movies, list of your genre of movies, and then fifth one just a random suggestion. Okay, then meta learning, obviously train a model, adopt a model that quickly adapts to the user's interaction, 5 to 10 interactions, and you learn about it. Then there is cross domain transfer. If user has Spotify data, um, you can get that data from Spotify. User has a Spotify data, and you can get that data from Spotify for his Netflix taste as well. Okay, but that requires very legal. That's a legal formality things. So much of it. Do not go into it exactly. Then content signals again. Metadata, genre, tags when items has no play, and then exploration budget. Um, I told you that last of the feed should be totally exploration based, that you can also explore other genres, or maybe just suggest other genres as well: action, romance, comedy, or maybe sports, something like that. And then early engagement loops, you know probably early engagement loops is something that is going to work by itself. Like once he starts interacting with meta learning, 5 to 10 interactions, probably he will see good personalization by day 3 and day 7. That's it with the cold start mitigation problem. But now the biggest of all, the new problem that has arisen is AI. Okay, now AI has probably broken off some barriers for all of us. Okay, since 2015 till 2022, the whole work was very manual thing. Like we always saw with the four models, everything has to be embedded and then coded by hand, and then the transfer model would come up and study everything by heart. Okay, but then you had to embed with the two towers, and then transfers, and then before that even deep weight, everything. Okay, deep fight model, and before that lambda model, all of that stuff you had to do it all by hand. Scores, you had to score everything. You had to like write with the all the hashtags and everything. Okay, but now with AI, like LLMs take a 20 to 2000 milliseconds per call. Yeah, when you call a LLM. Um, okay, when you add AI, but first of all, AI, like AI has like done a lot better than what we saw. Okay, so now what you can do is latency versus intelligence trade-off with AI. If you use you can use LLM always for offline embedding. Okay, not for online ranking. Otherwise, if you are having AI on the internet, it is gonna use a lot of your bandwidth and net. Okay, so probably maybe you want to use LLM in the offline. Okay, and then offline LLMs generate fluent but sometimes fall reason. Yes, hallucination LLMs. Um, LLMs can always hallucinate, and then probably if you say that I liked Harry Potter, mm, maybe just one of those days LLM is feeling bad and he would give you a bad suggestion. Who knows? Okay, and so probably there is always this risk. We'll come on to it, how to counter it. Okay. And then catalog size was LLM context window. Right now, we all know that LLM tends to forget things. You cannot just add so much of personalization data in LLM and ask it to read. Okay, like there are two stages to it now. One is ANN retrieval. Okay, and then like average next neural network. Was it this? What was the name of ANN full form? Artificial neural network retrieval. Okay, so probably if you're sitting somewhere and it would want to see what your neighbor is doing. Okay, so probably it will connect the 50 people next to you in the sense like those who liked Harry Potter and then all the 8 parts of Harry Potter, and then they went on to watch something similar like to you. So it is going to rank you, but it is on to you. How do you bring those 50 people together now? You have to bring it for, because LLM is kind of lazy in these kind of things. He cannot study this big of data. So probably you will have to bring it all of it together. Okay. And then probably some LLMs that are trained on web can amplify demographic biases in recommendation. Okay. For example, if I am an Indian and I'm living in SF, I am most likely to get the movies made in SF, or what are people watching. What if I want to see Indian movies? But it will keep suggesting me my demographic based suggestions. That's a bad thing. So it doesn't work like that. Okay. And then models collapsed in feedback loops. Okay. Um, okay. For example, if AI saw some content and started filling in those spaces by itself. Problem with an LLM is like it is that one uh, hypercharged in turn. If he'll see something, he will start doing it. Tuck 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 tuck. It will start nicking into those things. Okay. So probably if LLM sees a data, probably it is going to fill in those spaces. For example, he saw that you liked Harry Potter 1 to part 8. You might like Fantastic Beasts as well. Then after Fantastic Beasts, maybe you will like some another movie or series similar to Harry Potter, maybe Shadow and Bone, or maybe what else? What are Umbrella Academy? All of those series. Okay, you will like those, all of that stuff. It will think so. So it will start filling. Do you like those? Maybe even, maybe, maybe not. Okay, it's a big maybe. So maybe there should be a balance between human created versus AI created content. Maybe it will give your data recorders or event recorders like mowing gauge or what all those tools that you are going to use to record data, that it is going to record that probably, or it is going to create fake signals for you. So it is going to be very bad stuff for you. And then explainability and regulatory pressure and everything, you know. AI era metrics to add to your dashboard. This is the last probably. Okay. So probably one is explanation fidelity. Percentage of LLM reasons that match actual signals used. Okay. Um, Actual signals are that like what human event showed you. Okay. And what LLM created those reasons. It should match. Probably it should have a 90%, more than 90% match. If it is something less, maybe AI is hallucinating. The LLM is not that trustworthy right now. Okay. And then embedding stability. um, cosine similarity of item, embedding cross model version. Okay, again the same thing with the reasons as well. Now embedding as well. If embedding is right, only then you should proceed with it. You should not just take a look at LLM's reasoning at that point. Okay, and then AI content ratio in recommendation. Right now, keep it under 30%. Like if you see that AI is recommending a lot of stuff, maybe tone it down and keep it around 30%. Okay, AI can fire good in a good way or backfire in a bad way. Okay, good, fire in a good way because it will also read the personalized data that you created the whole model for, but it can also recommend in a better way with a good text, a good personalized text. Okay, user will see all of that stuff. But on the other hand, AI can also start mimicking the data that your humanoid custom model was showing them. So probably it can mimic that as well by chance. Okay, so it's a like very luck based thing with AI. It's like a golden genie that can produce anything. And then conversational recommendation satisfaction, you know, uh, CSAT score, watch it, like how good AI is doing. And then interference cost per recommendation. Um, It is kind of high, 1,000 recommendations per request. It should be $1 for 1,000 recommendations. Okay, you should keep it below than 0.10. That is only 10 recommendations by AI, right, on a home screen. Okay, and then demographic parity. Uh, that should be less than 5% by LLM. LLM, you cannot trust it. Okay, so that's it with the whole like recommendation models. Like we covered everything, like what recommendation models are, what was the layman definition of recommendation models, and then we covered how what are three types of recommendation models in a traditional way, how they evolved, what was the requirement of recommendation models also, and then how those three models, collaborative, context, and then content based, basically collaborative and context based, and then they formed hybrid, how they evolved over time, how content came into being. Okay, and then how do you score, we saw all the mathematics behind it. Okay, and then we went to further ahead that how do you apply or create this recommendation model. We saw the architectures, how you add weights or priorities in these models. Okay, what are the new age models, what are they called, and how do you use four of those models together now. Okay, and then we also saw some of the tools like FAISS by Facebook and SCAN by Google. You know, four of those models are Lambda, wide and deep, and then tutor, and then um, fourth is thrust hold. Okay, and then we saw what are the risks. Okay, of these models, like over personalization and everything. How do you mitigate those risks? And then what is your industry ideal industry standard for each of those models, like what you should do, what should not do, all of that stuff. And then at last it was probably the last one of all was what is AI doing in this field now? Like, how can you use AI? And then what are the challenges by AI? And then last was like what metrics you should see from AI to like how do you keep check on AI? So yeah, this is that. Thank you for watching the whole thing. Until we meet next time. Thanks for watching and yeah.